at the Manipal Academy of Higher Education. His research interests encompasses of population genetics, molecular evolution, an invaluable resource person for today's event.
Hello. Good morning, everyone. Um, so while they are still working on these technical things, I just want to ask you, all of you, so what are exactly your expectations from this workshop? If any one of you can volunteer, because what I will talk about is basically biostatistics in 2 hours. Biostatistics is a course that is being taught as a syllabus, as a full-time course. And in 2 hours, by no means I can cover 0.1% of what you should know. So that's why I should know what your expectation is. Accordingly, I can proceed with this presentation. And I can see many students are there. So many of you may not have had biostatistics ever. How many of you had some sort of biostatistics? Have you? Okay. So around 40%. Rest 60% did not have any biostatistics. That is another bigger problem. So basically what I will do today is okay, so I'll briefly go through the basics of it, and then we will do quickly some hands-on in GraphPad Prism. But if you really want to like know a little bit more about biostatistics and data analysis, I generally organize one workshop every summer. So sometime in June, July, I'm not sure exactly when, but it will be out as a brochure, and I will inform sir and madam. So we will circulate. That is a 2 weeks course, and it is obviously much longer, and you can we will go through every things in more details. Uh, so today is just an overview, and okay, and I would really expect that you will participate and you will just tell me what is more difficult, what is your understanding. There will be 2-3 sections which are solely for the interaction. Okay, so those who know, please interact. That will be helpful for the others who have not studied biostatistics. Okay, so as you might know, I am not a biostatistician. I am a human geneticist. So what the connection between genetics and statistics is me. So I combine genetics with statistics. So while going through, you will understand there is a little bit difference between pure statistics and biostatistics. Biostatistics is basically the application of statistics in biology. So you have to have biological knowledge to appreciate the data. Okay, so I will show you some data and you will understand why you need a biological knowledge to understand biostatistics. It is in sometimes something may be statistically significant but biologically irrelevant, or vice versa. Biologically significant but statistically non-significant. So for that purpose, you need that bridge between biology and statistics. Okay, so in last few years, I am trying to make that bridge and make students understand that biological statistics is a little bit more different than pure statistics. Okay, so let's start. So today I will be talking about more or less these parts, and let's see how far we can go. So this is right. Oh, okay, this one. So right now, this is the situation we are in. So whatever field you are in, whether you are doing wet lab, dry lab, bioinformatics, pharmacy, nursing, whatever field you are in, you generate lot of data. And I'm pretty sure in our medical college, there are lots of data just lying down. We do not know what to do with the data. How to get some meaningful things out of this data. For example, now all of you are sitting here, just sitting. But from here, we can also gather lots of data. So data is not only that you get from lab or from some computer. Data is everywhere. That's why data is everywhere. But we are like that blind man. We don't know how to deal with that data. Okay, so this biostatistics will give you an idea how to deal with that data in more meaningful way, so that you can get something out of this data. Okay, so quickly I'll go through a few slides. So before going any further, we need to know what a variable is. What is a variable in your data? So when you are dealing with any sort of data, you have basically two types of variables. One is quantitative data that you can quantify, count 1, 2, 3, 4 like that. And second one is categorical or qualitative, which you cannot count, like red, blue, green, all these colors and all, what you don't count, but that is still data. Okay, now this continuous data or the qualitative data can be of two types. One is continuous and second one is discrete. What is continuous? Where you can have some decimal place differences. For example, height, weight, your age, all these things are different kinds of continuous data. Okay. On the contrary, discrete data are count data, like number of patients suffering from diabetes. Discrete data. Number of people in this room. Discrete data, because these are counts. Okay. Then categorical data can also be of three types, or actually 3 or 4 types. Okay. So I think I'm loud enough, right? You can hear me. Okay. So categorical data can also be of 3 types. First type, which is not which is actually number 2 here, is called nominal data. What is nominal data? Nominal data means your name. Anything related to your name. For example, your ID. All of you have ID card. There's a number to it. You have Aadhaar card. There's a number to it. Voter's ID number to it. All of them comes under nominal data, which is your name and related information to your name. Does not have any order or rank. When you add an order to it, when you add an order to your name or that nominal information, that becomes ordinal data. For example, X student stood first in the class. So their name is there and the rank is also there. It together becomes an ordinal data. So ordinal data has an order. Okay. Finally, binary data, as you can all understand, is yes, no kind of situation. Right or left, up or down, only and only 2 options. Okay. So I'll show you briefly some different kinds of quantitative data and some are very interesting, I really like. I'll come to that. First of all, as you can see, it's the continuous data. Discrete, as I mentioned, are the count data, 1, 2, 3, 4, 5, those counts. And finally, continuous data goes beyond the decimal place. Now, one interesting thing. Have you noticed your foot? Your foot? If you measure your foot length, is it continuous data or discrete data? How many of you think your foot measurement is continuous data? How many of you think it's discrete data? That's good. So you have put it out. So that's correct. So it is actually continuous data. So if you measure your foot, it's a continuous number. You will get some decimal place, absolute number. But when you go to Bata or Ken's food store, whatever, whichever store you like, do they take your foot measure and make shoe for you? Until unless you are Ambani or Adani who has a lot of money and they can make your exact size shoe, you have to buy those shoes which are actually available. So if your foot size is 7.232, you will buy size 7 shoe. If your foot size is 6.896, you will also buy number 7 shoe. So shoe size is discrete. Foot size is continuous. So sometimes you have to adjust both. This is a classic example of that. Another thing, how many of you drive? Some people know that. So when you are driving, you see you change the speed changes, right? But suddenly it changes from 20, 30, 40, 50. Seems like it is sudden jumping. So seems like it's discrete. It's not. Speed is actually gradually changing. But our speedometer shows 20, 30, 40. So although seems like discrete, is actually continuous. The speed is continuously changing. Now, height I already mentioned. Height is a continuous data. Sometimes seems like it's a discrete data. Height is one of the classic examples when you have more and more individuals coming as samples. Your data will become continuous. I'll show that. Now you know. Now gender is not binary. Okay, but yeah, it's a categorical data. Let's stop there. Okay, ethnicity. You know what ethnicity is? Ethnicity? What kind of data? Ethnicity, can you count? Hindu, Muslim, like that, the Kannadiga and all these things. Can you count them? You cannot. It's an abstract concept, right? So these are all categorical data. Okay. Now, blood type. How many blood types are there? How many blood types are there? 4, exactly. So, what are they? I mean, blood types are A, what kind of data they are? Huh? Categorical data, okay. Categorical what type? Nominal data, yes. Because many people think it's ordinal. It's not ordinal. There is no order to it. There is no rank to it. It's just simple nominal data. You follow cricket? In India, everybody follows cricket. That's why ICC ranking is there. So ICC ranking. Ordinal data. These two things I really like here. Marathon and India's monsoon. I'll come to those two at the end. Cancer stage. Hypertension. Or let's take it ordinal. GRE often like test scores. Ordinal data. Okay. Shoe size already discussed. Let's come to this. India's monsoon. So we all like rains and like to see rains. Have you thought about rain can also be data, right? So what kind of data? India's monsoon. Think about it. Okay. I'll give you some clues. India's monsoon can have lots of different kinds of data, depending on what you are looking at. Okay. So suppose you are looking at which months it rained more. Okay, then you rank the months. It becomes, okay. Then you are a meteorologist. Your job is to collect the amount of rain every day. It becomes a quantitative data. Okay. And obviously quantitative continuous because it will be decimal places. Okay. How many states got good rain this year? Discrete data. Count data. So now whenever you encounter a word or anything, think about in terms of data based on your wish. Okay. Dependent variables are not under your control. Dependent variables are not under your control. You cannot change dependent variable. Dependent variable changes based on independent variables. Okay. For example, in this example, so there is a fertilizer X. That fertilizer you have chosen. So it is under your control. So fertilizer X is X, the independent variable. But depending on the fertilizer, how the plant will respond, that is not under your control. That is the control of that is under the control of the fertilizer itself. So that is Y, that is the dependent variable. Okay. So in every cases, for example, how much AC you will put, that is under your control. As increasing the AC level, how much cold you will feel, that is not directly under your control, it's the AC's control. Okay. So how much cold you are feeling is dependent variable, and how much AC to increase or decrease is the independent variable under your control. Okay. Now let's see this. Okay. So there are four shoe brands here: Nike, Reebok, Adidas, and Converse. Very well-known brands. They are sports shoes. Now the hypothesis is, if you wear these shoes, you can jump more. And in basketball, jumping is important because you have to put the ball in the basket. Okay. Now tell me, which ones are the variables here? And which ones are the independent variable? Which ones are the ones or one are the dependent variable? Shoes. Correct. Dependent? Jump. Again, this term you may have heard a lot of times, but we use this interchangeably. While they are not interchangeable, they are different. In many cases, if you are making a new, new tool or new test kit, anything new test that you will be testing for something else. For example, how many of you know RT-PCR? Many of you know RT-PCR, right? And many RT-PCR kits are being made. This company, that company, and all these things. Okay. They test all these things. It's one of the two important things that they test, along with sensitivity and specificity. Okay. So what is accuracy? What is precision? Accuracy is how close you can go to the bullseye. Bullseye means your target. How do you get the target? From either previous literature or from a previous company's manufacturer or something like that. So you have a target. If you are working in a company, you will be given a target. How close you can go to the target is accuracy. Okay. Precision is okay that you may not go to the target, but whatever you are doing, it should be repeatable. Okay. So, for example, as you can see here, these four arrows are nowhere close to the target, but all of them are falling at the same place. So they are highly repeatable. So precision depends on the repeatability. Okay. For example, if this is the ideal situation, most ideal situation, where your accuracy and precision are the same, you are going on hitting the bullseye again and again and again and again. Very good. Precision, high precision here, but no accuracy. Here, all of them are close to the bullseye. So high accuracy, but there is no precision there. And this is completely random. No accuracy, no precision. Okay. Now, if you are a researcher, honestly speaking, the most important part is to be precise than accurate.
Okay. Because if you are accurate, you are just proving a previous literature or previous known thing. If you can be precise, if your results are repeatable across the globe, you can actually do something novel or something better. Okay. Suppose you measured something and your measurement is 3.40 millimeter. Okay. Literature says the measurement should be 2.67 millimeter. Now you go to your guide, you tell, sir, I am getting 3.40 millimeter. Your guide says, no, it should be 2.67. You go back to a lab. This time you get 3.41. You go back, no, go back. Now this time you get 3.42. So every time you are getting 3.4, 3.41, 3.43 or 42. So your precision is very high. But it does not match the previous literature which says 2.67. Now your guide will be forced, or you will be forced to go back and check in the literature whether that literature value is correct or not. So being precise is more important than accuracy in research. If both are coming, very good, you are a lucky person. But even the other one is not coming, accuracy is not coming, make sure that you have high precision. And that gives you this slide. Repeatability and reproducibility. Right now, all over the world, I don't know whether you're aware or not, we are suffering from a problem of both repeatability and reproducibility. As I told you, there are lots of study articles come out every year. I personally have tried to repeat some of those experiments and get the same numbers. It doesn't come all the time. I don't know, if you just Google it and you will find out many articles are suffering from this problem of repeatability and reproducibility, which is the most important part in research. Since we are a research methodology workshop, so I'm really going to highlight these things. So what is repeatability? Repeatability means you repeat this multiple times. And every time you should get the same results. Reproducibility means you are not repeating. You are giving this to someone else, maybe some other part of the world, and they should be independently replicate your results. That is called reproducibility. Now, the more problem is reproducibility of the data. Okay, suppose someone has worked on X thing in US or UK. You should be, technically, if you follow their protocol, you should be able to replicate that in India. But can you? That is the question. If you can, the data has reproducibility. If not, it does not. Okay. I will not go through this mean median mode much. I'll directly skip the slides. A few things I'll go through. How many of you have heard about mean and median? All of you, obviously, the most common thing. But have you ever thought, why do we need median when we have mean? We have mean, right? Why do we need median? Because statisticians are crazy, they will go on finding one more statistic. So going on adding mean, then median, then mode and all that. Is that the reason, or there is a reason to use median? Research methodology workshop, so we should know when to use median. To use more precision, we yes. Skewed. The word is skewed. When your data is skewed, you have to take care of, like that will be taken care of by median. So the difference between mean and median is, mean deals with the actual numbers. 1, 2, 3, 4, 5, 6, 7, 8. They add it and divide by total number. So actual numbers are important. In median, the actual numbers are not important. Their position is important. So it's a position-based statistics. I'll give you one classic example. It's a classic example. Suppose I'll take the GRFs or SRFs here. So all of your salary may be somewhere between 25 to 26,000 maximum, maybe 20 to 25,000. And now, suppose all of you live in one hostel and your salary is 25,000 average. Okay. Now, suddenly, Bill Gates decides that he will move in your apartment. where average salary is 25,000. Now Bill Gates comes in, his salary, you can imagine, I don't even know how many zeros will be there, so let's not say that. Now you try to find the average salary of that apartment. What will happen? It will be very high because it will be skewed towards Bill Gates. Okay. But if you think about median will consider Bill Gates as an outlier. And their statistics will be still limited to your salary. Okay. This is how globally, have you heard about like the India's GDP growth is climbing out, India's number 3, number 4, and then, but average GDP is very low. This is the difference between the mean statistics versus the median statistics. Okay. So when you look at the median statistics, so it will be skewed towards the poorer people because we have more poor people in this country than middle class and the richer people. But if you take the mean, we have trillionaires in this country. They will take care of those poor people. So average will go up. So that's when you should think about where the data is coming and how they are being interpreted. As I told you, data is everywhere. So you just have to know how to interpret it. And as a statistician, I know we can easily make 1 to 4, 1 to 4, and 4 to 1 easily. And that's the job of statistics. I don't do that. I try not to ever do that. Just telling you that can be done. Okay, let's see what I mean, what it actually means here. So, this is a very interesting plot. How many of you know what this plot is? Anyone have seen this plot? Must have seen this in newspaper, journal articles or somewhere. This is called a box plot. This is the box, this is the whiskers. Okay. This plot is done to show the median. Okay. Now the central line here is the median. If you can see carefully, the central line is not exactly at the center. How many of you can see that? The central line is not exactly at the center. It is little bit shifted. Okay. The reason is, again, the purpose of median is divide the data set into exact half and half. So wherever the half position is, median will go shift there. Now let's see why it happened. So this is the central point, and if you follow this line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So median has to be where the middle is. It does not care whether it's at the bottom. So suppose all this data is clumping here, median will go down. Because it is not caring what is the value of the data. It is caring where the 10 ends, the position 10 ends. So again, it's a position-based statistics. So it can move. In many cases, you will see in articles, median is towards the bottom. Because there is more clumping of the data towards one side. Okay, so it can be nicely represented by this box and whisker plot. Now, sometimes to show median nicely, some people use a notch. This is the notch. And so from here to here, so if you just imagine as 100% total, this is 0, this is 25%, 50% is the median, 75%, then 100%. From 25% to 75% is your box, the box length. The box length in statistical term is called interquartile range. From 25th percentile to 75th percentile. Now, this is a very interesting place to ask you one question. Can anybody tell me what is the difference between 90% and 90 percentile? So you must have taken NET, GATE, or all these competitive exams. They will give you a score as percentile, not as percentage. What is the difference? So suppose you got 90 percentile, what does it mean? Did you get 90% to get 90 percentile? Exactly. So you are above 90% of the people. That is 90th percentile. You may not have got 90%. You may have got only 60%. But that 60% is above 90% of the people. That's why you are the 98th percentile. In most competitive exams, now people don't expect marks in terms of percentage because they will 100% as the person who got highest. Highest can be 70. Based on that 70, your percentile will be calculated. Okay. So here we are talking about this percentiles, not percentages. Okay. Another way to show this kind of thing is using something called, anybody have seen this plot? Looks like a violin. So it's a violin plot. Violin plot sometimes is better than box and whisker because violin will show you where the maximum number of data is, maximum amount of data is. You see, it has a big play in the tummy over here. It means the maximum number of data is actually in there. And box plot can have some outlier points, outside points, which does not fit in this 100 percentile calculation. Violin will never show that. It will show as a notch. Now, it's your wish. Do you want to show those outlier points or not? If you want to, use box plot. If you don't want to, use violin. Okay. So again, depending on your purpose or depending on what you want to show, we can change the plots. We can play around the plots. Okay. Mode range I'll skip. We'll come into this correlation and regression. We use this term interchangeably, but they are not the same from any angle. Because correlation does not have any causation. Correlation does not give you any cause and effect relationship. And correlation is basically comparing a number of independent variables. For example, I'm not a physiologist, I'm just giving a fake example. So suppose at 12 noon, the concentration of calcium increases in your blood, concentration of magnesium also increases at the same time. But the concentration of calcium does not have anything to do with the increase of concentration of magnesium. They are increasing independently, but there is a correlation. Both are increasing at the same time. So correlation does not assume any causation. I'll give you one classic example. In the summertime, okay, everybody have sunburn or some heat rashes, right? Also, in summertime, ice cream sales goes up. So, a person, suppose from another planet, will just think, whenever the ice cream sales goes up, you have skin rashes. Is that true? No. Both are related to the heat. So it's just a correlation that ice cream sales goes up in the summer as well as the heat rash happen in the summer. Okay, so this is the correlation doesn't have causation. On the contrary, regression can have a causation. Although in statistical causation, again, does not mean a biological causation. It's a statistical causation. What is the difference? Sometimes statistical causation may not rightly represent a biological causation. Okay, so whatever that is. So I showed you before. So suppose you are giving some fertilizer in this small plant and the plant is growing. So depending on the fertilizer, the plant is growing. So here there's a cause and effect relationship, is regression. Regression is unidirectional, from independent to dependent. On the contrary, correlation is movement together. It goes both directions. Again, regression has a cause and effect, but remember, this is statistical cause and effect. It may not be biological. Okay. TV is not making you fat or fat. That's not the case. Okay, that's a correlation. Okay. Now, perhaps if you forget every part of it, please remember this slide, especially those who are doing PhD, because in ethics, SRB, everywhere, they ask, the first question they ask, what is the sample size? So we will see what is the sample, what is the population. Why everybody cares about sample size? Okay, everybody asks that question, right? What is sample size? What is sample size? What is sample size? Nothing but sample size. So what is sample? Okay. Suppose you are working on the diabetes patients of Dakshina Kannada. We want to see the blood sugar level of diabetes patient in Dakshina Kannada. What is the ideal situation? You collect the blood sugar level of all diabetic patient in Dakshina Kannada. Do you think that is possible? No. So what you have to do it is, you have to get a sample of it. Right? So suppose these are the diabetic patients of Dakshina Kannada. And you are collecting a sample out of them. Okay. Now, the question is, you will never go back here and make the interpretation. Your interpretation based on the blood sugar level will be based on this sample and only on this sample. So your sample should be properly representative of the population. That's why people care about the sampling and sample size. If your sample does not properly represent the population, you will have a mistake in your study. Okay, so let's see. So there are different ways you can perform sampling depending on your purpose. But honestly speaking, in most cases, what we do is convenient sampling. That means we do not have that number of individuals coming that we can randomly choose anything. So whoever comes, we do just convenient sampling. You know, so whoever comes, we will take that. That's the convenient sampling. Convenient sampling is a kind of non-random sampling. Obviously, we do that because we have no other option. But in case, suppose you have unlimited amount of funding and unlimited amount of resource, what you ideally should do it, some sort of random sampling. Now, random sampling, I'll come to systematic sampling at the end. Random sampling are mainly of three types: simple random, stratified, and cluster. Simple random means all of us, or we were sitting here, have equal chance of being picked. So all of you sitting here, I'll close my eyes without any bias, close my ears, everything. I'll randomly pick someone of you. So all of you should have equal chance of being picked. That is called a random sampling. Okay. Stratified sampling is more, it's a more complicated design compared to simple random. Here you first group. So here many people are here. Some of you are students, some of you are staff, some of you are professor, some of you are director, different ranks are there, different categories are there. So you first group them based on their stratification. Suppose their rank. And from that stratification, you pick some of you randomly. So instead of randomly pick from any one of you, you first stratify, group them, then you randomly pick one or two. That is called stratified random sampling. Finally, the cluster, as the name suggests, here you are randomly picking a cluster instead of an individual. So here, suppose in Dakshina Kannada, there are many hospitals. KMC is there, Inapaya is there, AJ is there, Father Muller is there. All the hospitals are working on diabetes. Okay. Now, you randomly pick one or two clusters, one or two hospitals to work on diabetes. Here, you are not picking the individual, you are picking the cluster. That is the hospitals. Or sometimes, suppose you want to study malaria in villages in Dakshina Kannada. Then also, you randomly pick some villages to study. Instead of picking a person, you are picking a village. Okay, that's called a cluster sampling. It's also a random sampling, but here instead of a person, you are picking a cluster. Finally, as I told you, systematic sampling. Systematic sampling is in between convenient sampling and random sampling. In systematic sampling, the first person is chosen at random. So I close my eyes, close my ears, the first person I'll choose will be random. But from the second person onwards, it won't be random. It will be every third person or every fourth person, every nth person. Okay, that is called a systematic sampling. Okay. All of you must be knowing the normal distribution. In next 10-15 minutes, I'll stop and then I'll show you some hands-on thing, but like some more time. So you have heard about normal distribution, but have you thought about what normal distribution actually is? So all of you are sitting here. Can we make some normal distribution here based on something? Can anybody tell me? Look around each other. I'm pretty sure you have not even seen the person who is sitting behind you. Just check. Can we make some normal distribution here? Okay, color of the dress. But color of the dress is not quantitative. It's qualitative, difficult. There are other things we can do. Age, good. Gender is binary. No, not binary, sorry. Not gender is not binary, but category. Any height, very good. Classic example, height. Some of you are taller, some of you are shorter. Most of us are somewhere in middle. Okay, how many of you are more than 6 feet here? Everybody's looking at each other. You should know your height, right? You should not. So, okay, maybe 5 feet 11. Sir is there, 5 feet 11. Okay. Yeah, so 5 feet 11 maybe over here. Because we have quite short height, so 5 feet 11 will be here. Then, who around 4 feet 5, 6 inch, anybody? 4 feet 10 inch? Somebody must be there, but anyway. Okay, whatever. So those 4 feet will come here. But most people will be between 5 feet 1 to 5 feet 8, 9 inch. That will cover mostly the 68% area in the distribution. That 68% around 1 standard deviation up and down from the mean. 34.1 this side, 34.1 that side. Mostly average height around the mean. Okay, so most population will cover that. So as you can see with these bunnies, some are really big and fat bunnies, but really tiny bunnies, but most bunnies are somewhere in between. That's what happens. Okay, so if you have enough number of samples, it will ultimately take in the form of a normal distribution. Okay. And again, normal distribution is the only and only symmetric distribution. That means both sides same. Okay. Another thing that in research methodology comes again and again, p-value. How many of you know what is p-value? Yes, what is p-value, ma'am? Significance level. Significance level. So how do we measure that? So suppose this p-value or the significance level or alpha level, we pre-decide before starting your experiment. In most cases, biologically, it is 0.05. That means if your data falls in the 95% area, you cannot reject your null hypothesis. What is that? I'll come in the next few slides. But if it follows in that 5% that you pre-decide, your results will be significant. Significantly different from your null hypothesis. I'll show you what null hypothesis is. Basically, that cutoff, your significance level is that 0.05, your p-value. Right. That brings to this most important question in research methodology. What is a null hypothesis? Now, one very important thing you should remember, research hypothesis versus null hypothesis is very important to know. Research hypotheses are your objectives or the hypothesis that you write, aims and objectives, then you write a hypothesis. That is a research hypothesis. Null hypothesis is a converted from a research hypothesis which can be quantified or analyzed based on certain parameters. Okay. It can be mainly of two types, null hypothesis and alternate hypothesis. But again, there can be many alternative hypotheses against a single null hypothesis. Null is always single hypothesis. For example, my null hypothesis, I am measuring the height of people here. My null hypothesis can be all of you are of same height. There is no variation in height. So there is no null, that is the null hypothesis. Null hypothesis is the hypothesis that you want to reject in your experiment, through your experiment, because obviously we know there is variation in height. So you want to reject that. So based on that null, we can create several alternative hypotheses. One alternative hypothesis will be males are taller than the females. Okay. Younger people are shorter than the older people. Correct. So there can be many possible alternative hypotheses under the same null that all heights are equal. Understood? So you would like to accept your alternative and reject your null. Based on what? That p-value, that significance level, that alpha level. Okay. Now, this is a funny thing, but if you remember this fun, you will never forget what is an error. Okay. This is completely a joke and only used for a joke purpose. Okay. Don't take it seriously. So, this man, the null hypothesis is you are not pregnant. That's the null hypothesis. Okay. A man goes to a doctor and doctor says you are not pregnant. No problem. That is true negative. Okay. The man goes to a doctor and doctor says two kinds of errors. One is type 1 error, one is type 2 error. Type 1 error we designate by alpha. This alpha is under your control. That 5% level of significance, 1% level of significance, 0.05, 0.01, that you start with. It's under your control. On the contrary, type 2 error or beta is not under your direct control. Type 2 error or beta has direct correction with the sample size. The more and more samples you have, the chance of beta will go down. And chance of the correct decision, 1 minus beta, which is also known as the power of the statistics or the study, will also increase. That is why sample size is so important. The more samples you have, the correct decision, chance of correct decision will go up because the power will go up. Okay, so that is the most important part here. That's why we need enough number of samples to do a study. Okay. Now, if we are going any further, just to compare the two. Okay. Both errors are problematic. First, let me tell you that. But type 1 error sometimes is less problematic than type 2 error. If you think about a customer, suppose you are a customer and seller. Suppose you are gone to a departmental store, okay, and suppose you as a customer, and the people who are selling are the seller. On those terms, type 1 error is the problem of the seller. Type 2 error is the problem of the customer. There is only one seller, but there are many customers. So type 2 error can have a long-term effect than a type 1 error. What does it mean? Let's see this. Suppose this is a null hypothesis. We are looking at a fire alarm. Fire alarm you are all aware of. Okay. So our null hypothesis is there is no problem in the fire alarm. Okay. What is type 1 error? Type 1 error is the probability of rejecting the null hypothesis when the null hypothesis is actually true. Okay. And type 2 is the probability of accepting the null when the null is false. Okay. That means type 2 will say there is no problem in the alarm where actually there is problem in the alarm. And type 1 will say there is problem in the alarm where there is no problem in the alarm. Now what does it mean? Suppose one day, one fine day, the alarm does not ring. Okay. Now there are two possibilities here. The alarm, there is no problem at all. Alarm is fine. There is no problem. Actually, there is no gas leaking. Nothing is happening. Possible, you are safe. Now there is actually a problem outside. There is some fire or smoke. Something is there, but the alarm did not ring. That is the type 2 error. Alarm is thinking there is no problem, where actually there is a problem. It will cause disaster to the entire room. That's why it says. So it can lead to a disaster. Type 2 error generally leads to a disaster. I'll give you one more example. Why we care about sample size, you will understand better. Suppose, have you seen a short flights from Bangalore to Bangalore? They run short flights. They call it ATIR or AT or something. They call it the short charter flights. They hardly have any space. Okay, and they are very careful amount of the luggage you carry in that flight. Okay, so here null hypothesis is all luggages are within the limit of that ATIR flight. That's the null hypothesis. Some of you actually carry heavyweight luggage in that flight, but nobody cared. They are doing a type 2 error. Type 2 error means they will say there is no problem in the luggage, while there is some problem in the luggage. Now what will happen? ATIR flight will be overweight and crash. So it can cause a disaster. That's why sample size is very important to give you enough power so that you do not cause any type 2 error. Understood? Obviously, type 1 error is important, but type 2 error is even more important. That's why in SRB, ethics, everybody, they care about sample size. Sample size directly related with the type 2 error. Understood, all of you? But type 2 error can have a long-lasting effect. I already mentioned. So see this cartoon. This is your null, this is your alternative. When there is a substantial overlap between null and alternative hypothesis, you will have higher type 2 error, beta. But if the null and alternative, or your control group, expert group, there is no overlap, type 2 will be very small, power will be the highest. It is the ideal situation in the world, where your two groups are very different. But in real life, it does not happen. There will be an overlap. Your goal is to have enough number of samples so that you can overcome that problem. Suppose you are making one toothpaste. Okay. You claim that your toothpaste has rock salt, and that is better than Colgate in the market. Okay. If your toothpaste actually have higher quantity of rock salt that Colgate toothpaste don't have, you don't need that much of samples. Because one or two samples will show that. But suppose your toothpaste have 0.75 milligram rock salt and Colgate have 0.7 milligram microgram rock salt. Almost same. How will you show the difference? There is a substantial amount of overlap there. So you need to have more and more samples to have less and less standard deviation so that you can show some difference. Okay. That is why, again, sample size is very important. Second concept, again, is very important concept, is something called effect size. Effect size is the difference between the two groups. Group 1 and group 2, whether it's control group or experimental group, whatever you can imagine. The difference between the two groups is the effect size. How many of you use Android phones? Most of you, right? All of you. Take out your phone and have a look. You may use Samsung phone, you may use Vivo phone, Oppo phone. Every day one phone is coming. But have you noticed they look identical? If you change the brand name, no one will know which company phone is that. Until and unless you compare your Android phone with Apple phone or iPhone, obviously you will see difference. Don't need that much of samples because they actually look different. Design is actually different. See these ones. So the more the overlap, the D, so coherence D, which is calculate the size. When the two groups are overlapping, D is very small. D is very small. When the two groups are non-overlapping, the D is high. The more and more the difference, the D will be higher. I'm not going to the expressions here. Now, there's a direct connection between the effect size and the sample size. The larger the effect, the smaller the sample is needed. The smaller the effect, the larger sample will be needed. It is shown by this graph, if you can follow. So suppose this is sample size. When you have a large effect, you need less than 50 samples. But as the effect goes down, the number of samples required will be larger. So you may know what you are doing in your whatever experiments you are doing, and based on that, you are the best person to know how many samples we will actually need, because you know what experiments you are going to do. Sample size calculation I will not show through effect size. Again, if you are interested, you come to my workshops in summer. I'll show you more details. I'll rather show you the most common one to calculate the sample size from the prevalence. Okay. So most of us must be doing some biomedical data. So in biomedical studies, the most important way to calculate sample is basically through prevalence. What is prevalence? Prevalence, how many of you know what is prevalence? Prevalence of a disease? New cases. What is the difference between incidence and prevalence? New case, correct. And prevalence? Incidence multiplied by the number of disease years. In cancer or AK, we consider 5 years. So basically, incidence multiplied by 5 will be prevalence. It can be 10 years, it can be 2, that vary, but incidence is the new cases. Prevalence is how many people are actually having that for a particular period of time. Okay, so that you will get from some sort of literature, you will get this p-value or the prevalence value. Okay. Now, once you get the prevalence value, there are a few constants here. The Z alpha is a constant that you decide before, as I mentioned, alpha is pre-decided. And for alpha 0.05, Z value is 1.96. So it's a constant. Okay. So it's a constant, we already decided. Precision. Precision is interchangeable. Generally, for most studies, we consider 5% of error. In that situation, precision is considered to be 0.05. But again, it's up to in your hand. For example, especially, if you are working on a disease whose prevalence is very low, for example, if you are working on some sort of cancer, the prevalence of cancer is generally below 1%. When you are doing a study with like cancer and any other rare disease whose prevalence is below 1%, D cannot be 0.05. Because it means that for a disease whose prevalence is 1%, your error is 5%, which is wrong, which is not possible. So in those situations, D has to be lower than this. Maybe most common diseases like diabetes, hypertension, cardiovascular, all these diseases which prevalence is more than 10%, you can aramsey use precision as 5%. Okay. Then you plug in the number and you get your desired sample size. Okay. Now, there's a twist here. The twist is, suppose you do not know the prevalence of the disease. It is possible. In that situation, you have to use p equal to 0.5. And if you use p equal to 0.5, you will have a large number of samples to study. Okay. So basically the logic is, as p goes towards 0.5, sample size goes up. If p goes towards lower side, sample size goes down. Upper side, sample size goes down. But when it goes towards the middle, sample size is the highest. For a disease like COVID, where most people got infected, so p is around 0.9, your sample size required is very small. If you think about a rare disease whose prevalence is around 2% or 3%, p will be again low. Okay. But if you're talking about diabetes, sample size is very high. I told you many things. I do not have any time to discuss about all the statistical tests, but this one slide will give you an idea when to use what kind of tests. Okay. For example, the first question comes to mind is, what kind of data you have? If your data is categorical, that means it is not quantitative. The way to do it is some sort of chi-square test. Some sort of chi-square. There are many kinds of chi-square tests are available. Again, if in future, if you get opportunity, I'll show you there are many kinds of chi-square tests. But some sort of chi-square test has to be there when the data is either discrete or categorical. Now, the second option is your data is quantitative and continuous. your data is quantitative and continuous. In that situation, you can have two options. That depends on the question you are asking. Are you looking for any relationship between two variables, or you are trying to find any difference in the two variables? So the question is, are you looking for any relationship in the two variable, or you are trying to find any difference in the two variable? Okay. So if you are trying to find any relationship, then the question will be, is there a dependent variable? If there is a dependent variable, your test will be a regression. If you do not have a dependent variable, your test will be a correlation. Okay. Now, if you are looking for the differences, then the question will be differences between what? Are your tests looking for the difference between the means, or you are looking for the differences between the variances? We'll skip that. Really, most cases in biomedical research, we look for the difference in the mean. So let's take the difference in the mean. When you are looking for the difference in the mean, the next question will be, how many groups? If you have two groups, then you will do a t-test. If you have more than two groups, you will do some sort of ANOVA. Okay. Why I'm saying some sort of, because there are many kinds of ANOVAs are there, many kinds of t-tests are there. Okay. So you have two groups, more than two groups. Now, you have two groups, but is your data paired? That means, do you have any before and after kind of situations? For example, before coming to this workshop, you had some sort of idea about statistics, most of you. Now, I'm giving you some more idea. It may help you, it may not help you, may not help you is the neutral one, or it may cause ulta, some problem. Whatever you knew, you forget that and something all become all ulta. Okay, all three possibilities are there. Okay, so in that situations, you do something called a paired t-test. Trust me, that happens. I've seen that. So some people knew something. I did some assessment test. After I did some lecture, whatever they knew, they forgot that. Something new has come up. So that's why you have to be very careful. Then, if there is no group, no before-after situation, two independent groups, then you do something called an unpaired t-test. So paired t-test when you have paired data, unpaired t-test when you have two different independent groups. When you are doing two independent groups, the question is the variance? I'm not going into non-parametric. It's a different story altogether. So even if you have this, so now you have more than two groups. As I told you, if it's more than two groups, you do some sort of ANOVA. Okay. Now in ANOVA, depending on how many factors you are incorporating, it will change. If you are incorporating one factor, suppose height, only height, one-way ANOVA, height and weight, two-way ANOVA, height, weight, time, three-way ANOVA. It goes on changing depending on how many variables you are putting in the data. Okay. So, any questions? I have 40 minutes to show you some demo. Any questions here? When I ask these questions, I'm the most scared person because I know nobody will ask me any questions. I told this many times. It means two things. Either you have understood everything or you have not understood anything. So there are only two options. Okay. So, anyways, I'll consider that you have understood everything and I have done a great job. Yeah, one question is there. Yes. Sir. Okay. I did not go through non-parametric. No. The non-parametric counterpart of ANOVA is Kruskal-Wallis. Non-parametric version of ANOVA is Kruskal-Wallis. The non-parametric version of t-test is Mann-Whitney test, Wilcoxon-Lang sum test, Wilcoxon sign-Lang test. These are non-parametric version of t-tests. Okay. Very good questions. Okay, I did not want to go there, but okay. So parametric test means it assumes a normal distribution in the data. But in many cases, your data will not be normally distributed, or you think that your data is not normally distributed. There are some statistical tests that you can perform before you performing any test, which is called a normality test. In normality test, if it shows the data is normally distributed, you can aram se do parametric test. If those test shows the data is not normally distributed, you have to perform some sort of non-parametric test. Now, besides normality, there is another factor that is important, is the sample size. If you have a smaller sample size, better to do a non-parametric test than a parametric test. Now, the question should be, how small is small? If you ask me, my personal experience, 3 biological replicates with 3 technicals each, that means 9 data points, is more than enough to do a parametric test. Okay. So, all of you know what is the difference between biological replicate and technical replicate? So, when you are performing an experiment, you do this in triplicate at a time. Those are your technical replicates. Now, you go back to your main source, and again another day, you freshly perform the experiment. That will be your biological replicate. Okay. So, generally, it is suggested that you should do 3 biological replicates, and if each time you do 3 technical replicates of each. If that is the situation, you are fine. You can aramse use a parametric test. Okay. Non-parametric test should only be used in certain situations. For example, suppose you are working on psychological data, or you are working with subjects like animal behavior, ecology, field ecology, where the data is have more heterogeneity. In that situation also, non-parametric is a better option. Okay. I don't know how many of you work on psychological data? Anyone has psychology or any psychiatry kind of data? So why that is important is, most cases psychological or psychiatric data or animal behavior kind of data is based on what the person is saying. The measurement is not it's kind of erratic. So in those situations, it's better to use a non-parametric test. Otherwise, parametric is fine in most cases, until and unless you see a huge difference in those tests. Yes. That is the thing. So people do non-parametric because other people are doing non-parametric. So if you start doing non-parametric here, everybody will do non-parametric because they think that is fancy. There's no other reason. No biological reason here. Both are correct. Both are correct. You have to interpret it correctly. So that's I told you. So if you have enough number of replicates in your in your experiment, better to go for a parametric test than a non-parametric test. Especially if you are looking for a relationship. Okay. Lewis correlation kind of thing. It's always in capital, better to go for a parametric test. Non-parametric tests are not good with relationship. Spearman's rank correlation will rank between 1, 2, 3, 4 based on your numbers. You want to go into that, you showed you. Will always be biased towards high relationship. Okay. But if you are doing t-test or ANOVA, both parametric and non-parametric are okay. Okay. But as in my statistics teacher used to say, and I also believe that, it's always better to start with parametric. If you have some problem, if you think some problem is that in your data, then only go to non-parametric. Don't go into non-parametric directly. They are both okay, they are both fine. Nowadays, it's a fancy that everybody works on non-parametric. Okay, because most cases I should not say that reviewers who review this, they also are not very good in statistics. They like to see those Kruskal-Wallis or Mann-Whitney, all these things. But they are equally good than normal t-test or normal ANOVA. There's no problem in there. Okay. No, ANOVA variation means? Doesn't care. Non-parametric test doesn't care about those things. Non-parametric does not have a normal distribution. It has a different formula altogether. Okay. So non-parametric test converts the numbers into ranks. Once converted into ranks, those numbers become irrelevant. The entire experiment is based on the rank. Okay. So there are some formulas I would have showed. Like Again, if you come to my the long workshop, I'll show you non-parametric classes I already take. There are some formulas which they plug in and get those values. Okay. And they also have separate tables to look at for the non-parametric test. Type 1, type 2, irrelevant here. There is no normal distribution here. Yes. Yes. Yeah. Yes. Yeah. In that situation, non-parametric is a better test. Yeah. Covariance. When two or more variables go together, we call them co-varying with each other. For example, give an example of the calcium and magnesium. They are both changing together based on something. We call them co-varying with that something. That's called covariance. And the co-varying is calculated based on covariance. I do not have time to show covariance formulas and all. It is basically based on the correlation only. Okay, but they try to find the difference in the both parameters and multiply. Any other question? If you really come for my workshop, I'll circulate that. Yes. Exactly. So as Sari said, that's a very important thing. The goal of this p-value is to reject the null. It does not prove the alternate. Now, important thing is, that's why I've said in the beginning, there can be multiple alternate. When you are rejecting null, it means, it does not mean you accept that alternate. It means that null is not true. You can have multiple alternate hypotheses. Okay. So, for example, that's why we do always both direction. In t-test ANOVA, we run both direction. Suppose I'm looking at the diabetic patient's blood sugar level is around 160. Let's take 160. Okay. Now, that's your null hypothesis. You want to reject it. You want to see diabetes should be higher, but it should be higher than 160. So, it is also possible that in some cases it can go to the other direction. So, we always do both sides of the normal distribution. We always do t-test both sides. ANOVA, actually the problem with ANOVA is ANOVA by itself is one-sided. It cannot take the other side. That's why, followed by ANOVA, we do something called multiple comparisons. That can also consider for the both sides. Because against one null, as I said, can be multiple alternatives. I'll just move. This software that I'm showing you is called GraphPad Prism. It's a very useful software and very student friendly. Okay, and the plots that it makes is also very good. Okay, so the software name is GraphPad Prism. Sadly, it is not a free software, but the good thing is this is the software, GraphPad Prism. This one, this is the software, GraphPad Prism. It is not free, but many people have, at least in YRC, everybody has some sort of the GraphPad Prism. Okay, so it is a very useful software. It can perform most tests, if not all, and the plots are also very good. You can make various different kinds of plots. Okay, so I'll show you a few data that we will analyze and show how to do it. Okay. Before coming here, I'll show you what different designs it has. Okay. So, when you open a new GraphPad Prism, again, in more details I can show you if you come for a longer workshop, but just to give you an idea, this is the GraphPad Prism first page, front page, and it has different ways of putting data in. Okay. The first one, XY, is used for correlation and regression. Okay, the first one. XY is used for correlation and regression. The next one, column, is generally used for t-test and one-way ANOVA. Okay. The third column called grouped, it is used for two-way ANOVA or three-way ANOVA, but this two-way onwards, any kinds of ANOVA, it is used in grouped column. Contingency is used for chi-square. Chi-square plus, chi-square, Fisher's exact test, G-test, odds ratio, risk ratio, everything is done using contingency. Survival is used for survival analysis. Survival analysis, you may have heard about it. It's not time to show you how survival analysis is done. Basically, how many individuals survive after some period of time, based on two groups, case and controls, treatment and control, kind of that situation. That's why survival analysis. Parts of whole is used to make a pie chart. Okay. Multiple variables, as the name suggests, it is used for multiple regression. Multiple regression, linear regression, logistic regression, all sort of regression is done by multiple variable. Finally, nested. Nested means when one variable is nested inside another variable, that is called a nested analysis. For example, suppose, how many of you have seen the petri dish where you grow the E. coli and all? Must have seen microbiology, right? Now, you are giving different kinds of nutrition in different plates. Okay. And you are trying to find the microbial growth in the plate. Now, when you consider the microbial growth in the plate, you are only considering the nutrient that is given in the plate. But the nutrient is inside that plastic plate that you are not considering. But it is possible that those plastic plates are not equal size. Because who is making in a bulk? There may be difference in the size or shape or something in those plastic plates. But the effect of those plastic plate and the media or whatever nutrient you have given comes together as a package. That kind of analysis is called a nested analysis. Where effect of one is nested means the effect of other. It's called a nested analysis. So, yeah, nested analysis are rare, in a rare situation we do it, but these are very common. Commonly it is done. Okay. So I'll try to show you different designs. The good thing about GraphPad Prism is it will make the plot by itself. It is smart enough to make the right plot. You can then later use your human brain to modify it and all that. Okay. But it does a good job. So the design that you see in front of me, all the things that I will show you are real life data. So real life data has lots of noise. It's not a fake data. So here we are comparing, the good thing is this data is from here only. It is from the homeopathy hospital, your next building. Okay. So this data is from here, so I'm showing you. Okay. So we are comparing the vehicle control VC with 3 treatment groups. When the person came to me with this thing, he was expecting it will be one-way ANOVA because he was only thinking the control versus the 3 treatment groups. But the data he had also had one more component. That was the day. So there was day-to-day variation. So when you consider this day-to-day variation along with the treatment versus control, you right away jump into from one-way ANOVA to two-way ANOVA. Okay. Because day time is also a factor. That's why I mentioned biological replicates or technical replicates. It's a very important things. Here, I think, as far as I don't remember completely, I think he did independently for 4th day, 8th day, and 12th day. So in this kind of situation, you do something called two-way ANOVA design, where your table format is grouped. In group, the column-wise, you will put the treatment, and the row-wise, you will do the days. And when you get the results, I'll show you one way ANOVA also, you will be able to understand it better. ANOVA results, you see, then it will show you which ones are significant. The interaction between day and treatment, like day-to-day variation is significant. That means there is an interaction, there is a variation between day versus treatment. It's called the interaction term. That is significant. Raw factor, day-to-day variation by itself, significant. Column factor that you are actually testing is also significant. Now you can ask me, this is what I care about. I don't care about this too. Doesn't matter. You have to also mention these results. Those who know statistics will know the importance of this term. Because it means there is a substantial day-to-day variation. So maybe you need to one more time to decrease that interaction term. Because there is a day-to-day variation. Either manual reason or whatever reason you are doing, you're doing something is going on there. Okay. So ideal situation, if this interaction term is low, this value is low, the percent of variation is low, you are very good. So the percent of variation is 7%, more than the column percent or column variation. It's not an ideal situation. Again, when you write your manuscript, put your results, most peer review process will not notice all these things. But this is worth noticeable. Your main variation, main percentage variation is actually the day, not the column. 85% variation lies day to day. You understand the difference what I'm trying to say? So in this kind of situations, maybe it is better to have a look. Maybe an independent biological set, maybe something like that, to see whether you're getting the same thing or something else is going on. But we are in the world where we try to publish as much as possible, as quickly as possible. Yes. As low as possible. Yes, absolutely. When they are totally independent, that will be non-significant. But in real life term, they are not totally independent. There will be some interaction will be there, but it should not be more than your own, the thing that you are actually testing. What he is saying is ideal situation, totally different, no interaction. That is the ideal situation. Now, I'll remove something and show how one-way ANOVA does. I'll make file, new project file, and I'll put column here. So here, I have taken the data from 8th day. So there is no day-to-day variation here. Okay, all are 8th day. Now only difference here are the different treatment groups. So first one is obviously VC, the vehicle control. Treatment 1. Treatment 2. Treatment 3. To do this, you go to analyze. One-way ANOVA. Now, as I mentioned to you, one-way ANOVA by itself cannot be both directional. ANOVA is always unidirectional, one directional. But as we discussed, against one null hypothesis, there can be multiple null hypotheses. So you have to find a way so that you can see both sides of the story. For that, here we do something called multiple comparisons. What does multiple comparison do? It will perform t-test, basically analog to t-test, based on the variance that is given by the ANOVA. Okay, that's why it's called the post hoc test. In this post hoc multiple comparison, generally the commonest one that we use are called Tukey's multiple comparison or Tukey's post hoc test. Okay, so we will compare mean of each column with mean of every other column. In ANOVA, we focus on variance, but t-test we focus on mean. Since it's analogous to t-test, again we are comparing the mean of each column with the mean of all other columns. So you can see there is a significance there. When we did two-way ANOVA, the significance was 0.0001. Now day factor we have removed. Significance level has come down to 0.01. It just shows that the amount of significance that we were getting was mainly given by the day factor. Here day factor is not there. Significance gone, but still is 0.01 is there. Let's see multiple comparison. Which group is significant? VC versus TR1 is significant and TR1 and TR2 are significant. Only two are significant. Even with VC, TR2 is not significant. That's what I was making the point there. Only 4% variance came from the column to column variation. This is the outcome. When you remove those factors, there will be significance, but very limited. Because the actual thing was guided by the day factor. Sounds a little bit complicated, but if you think about, there are two factors here. One is the day factor that I showed you, another one is the actual treatment versus vehicle control. Now, I did not consider day factor because I only considered 8th day samples. And you can see the significance level have gone down. Only two groups that are significant are vehicle control versus treatment 1 and treatment 2. Others are not significant. So that's why when you perform an analysis, first try to find out how to interpret your results. It's very important. Sometimes we tend to over-interpret our results. We should not be over-interpreting our results. If you have any doubt, talk to any statistician or anybody who will help you to actually interpret your results. Okay, because sometimes you never know. Whoever will be reviewing your manuscript during peer review may be actually good in statistics, you will catch. So show your manuscript to a statistician, consult somebody who will better tell you whether he's over-interpreting your thing or not. Okay. Now, how to do t-test? T-test, as I mentioned to you, are only two groups. Only two groups. So, analyze t-test. Okay. Here they will give you option. Unpaired t-test, paired t-test. If you have two independent groups like here, control versus test, you are doing unpaired t-test. But if you have a paired group, like same individuals before and after, you have to do a paired t-test. Okay. So here we do unpaired t-test. Next option is, does it assume normal distribution? If it does, parametric test. If it does not, non-parametric test. Okay. Default is always parametric. Now, third option. Third option is, does your unpaired t-test assume equal variance or unequal variance? That means, does it assume that both populations have the same standard deviation? Variance is square of standard deviation. Or it does not have equal variance. That way, you will choose either student t-test or OH t-test. Okay. Default is student t-test. Okay. Now we will put OK. And you can see. Now, if you remember, when we did multiple comparison, we also got the significance between the vehicle control and treatment 1, right? So same thing. I told you that is analogous to a t-test. So again, you get a significance here. But obviously, since it's a t-test, you get a t value. There, you don't get any value. Any question? Yes. Regression, okay. I'll show you results, example of both correlation as well as regression. Which one is relevant where? Okay. So for correlation and regression, we use XY. Okay. You put how many values you want to put. So, So I have plugged in the numbers. I plug in the numbers. Okay. Now, sadly, in graph prism, X means Y and Y means X. Because you have only one variable as X, that is your outcome variable, that they call as X. Okay. You can have multiple Y's, these are not Y's, these are all X's. Okay, please listen this carefully, it's kind of counterintuitive. In graph prism, X means Y and Y's mean X. Remember, outcome variable can only be one and only one. The independent variables can be multiple. Okay, that's the logic of this multiple regression or regression. So here first we are doing correlation, so direction does not matter, XY does not matter. So we will first do a correlation. To analyze, the option is non-linear regression, linear regression, lowest, all this curve fit, all that. There is option called correlation. We click on correlation. Okay. Now the option will be compute R for X versus every Y set. And second option is compute R for every pair of Y data set, that is a correlation matrix. We'll go for this one. Now again there are two options. Pearson's, which is the parametric version, and the non-parametric Spearman's rule. Both options are there. We right away go with the Pearson's. We'll go for two-tailed test. R is 0.46, which is moderate, not very high, but significance is there. We have compared 29 pairs. Also give you a regression coefficient, which is 0.21. This is the square of this. Is again not very high, but significant. Now we'll go back to our data and analyze. This time we will do a linear regression. Okay. Now see, lots of options will come. I personally do not like this. This is something not correct. Many of the graphs, most people would like to force the line, regression line, go through zero, which is incorrect. Okay. So you should avoid that. You should never check on this. Okay. Rather, one very interesting thing or good thing you can show is the 95% confidence interval along the base fit line. That will show you the distribution of the data nicely along the line. And okay. So we already knew the regression value R square 0.21. Okay, now one thing I did not mention before, small r is correlation, capital R square is regression. Now, small r square is analogous to capital R square. Okay. Small r, when you square of correlation, is analogous to regression. Okay, although they do not mean the same thing. Because the mathematically they are the same, because only the one has direction, one does not have direction. So mathematically they are the same, but biologically they mean very different. That's why I said now biological and statistical meaning sometimes is different. So here I generally spend one class at least on correlation regression in my classes. So now I will show chi-square. This is the chi-square setup and coming from contingency. Chi-square, the table format is called contingency. What does it mean? And trust me, chi-square is one of the most important test statistic in biostatistics coming after t-test, or maybe more important than t-test sometimes, because it has a set of tests and all of them are equally important. Okay, so this is the design. Suppose in here we are comparing whether age has anything to do with the symptomatic COVID. That's what we did in our lab. So these are the individuals who are symptomatic COVID, individuals who are asymptomatic but COVID patients, age greater than 50, age less or equal to 50 years. And as you can see, chi-square only in capital O-N-L-Y works with the count data, either discrete data or categorical data. So chi-square does not work with any continuous data. It can only work with the count data or the categorical data. So that's why we put the counts. Okay. Then you go to analyze. As I mentioned, Dr. Prism is very smart. Whenever you put a contingency table, you automatically bring a chi-square there. Okay. But when you do your chi-square by yourself, you can explore more options. You do chi-square, okay. Now see, there are many options come. I have checked all the options. Options are relative risk, then difference in the proportion, odds ratio, very, very important, odds ratio, sensitivity, specificity, positive predictive value, negative predictive value. This all comes as a package with chi-square. Chi-square design can give you something called a confusion matrix. This confusion matrix can give you all these values. So it will give you, now we have three choices for doing chi-square. Either you can do Fisher's exact test, Yates corrected chi-square test, or normal chi-square test. When we have a 2 by 2 table, that means 2 rows and 2 columns, 2 rows, 2 columns, that situation, it is always better to perform a Fisher's exact test, because Fisher's exact test calculates a p-value directly without going into chi-square table. So there is a formula, p equal to, it goes to, multiplies the row total and column total, and it goes into their factorials. I don't want to go into the formula, but it can directly calculate the p-value. That's why Fisher's exact test, exact means exact p-value, it will give you. Okay. Right? Fisher's exact test is only limited for 2 rows and 2 columns situation. If you have more than 2 rows or more than 2 columns, you cannot use Fisher's exact test. You have to either come to Yates t-test or Yates chi-square test or normal chi-square test. Okay. Then you hit OK. Obviously, this was done. It was not different. So, as you can see, it's highly significant. See the odds ratio. 4.0001. This odds ratio means, again, to get the correct odds ratio, your contingency design has to be very correct. In the contingency table, your design should be what your hypothesis is, what you are testing. The thing that you are testing should be on the top right. Okay. Suppose you are testing that individual alternative hypothesis is individuals who are more than 50 years old have higher chance of symptomatic COVID. If that is your hypothesis, then symptomatic should be on the left side and both the 50 years should be on the top, because this is what you are testing. Is it clear? So whatever you are testing should be on this side. The age that you are testing should be on the top. The symptom that you are testing should be on the left side. That is the design. Then only you will get the correct odds ratio. Now let's see what odds ratio we have got. So odds ratio we have got 4. This 4 odds ratio means individuals who are more than 50 years old have 4-fold more chance to develop symptomatic COVID compared to individuals who are less than 50 years old. Understood? I'll show you one very interesting chi-square. I mean, you will, I hope I have downloaded. I have not downloaded, so I don't have it. Actually, yesterday only I saw one odds ratio of 10 for one psychiatric disorder. It was very strong. I thought I downloaded, I did not download. So those are very strong things. Now one more thing I would like to, I have 1 minute. In the 1 minute, one thing I would like to focus here is when you are explaining your odds ratio, along with that, you have to put the 95% confidence interval. Odds ratio by itself can sometimes be meaningless. If your odds, your 95% confidence interval is long or broad, your odds ratio will be meaningless. Your confidence interval should be compact, should be very small, and your odds ratio, the value you get in the odds ratio should be exactly in the middle, like here. So it is not skewed, it is very compact, so this is a very good odds ratio over here. Okay. I think I have to stop here. So again, whenever, yeah. Yes. Yeah. This one is actually, for chi-square, there is nothing called graph as such. But for t-test, ANOVA, I'll show you the graphs. So is that a one-way ANOVA plot? It will automatically generate, and this is basically up to here is the mean. And this error bar can be either standard deviation or standard error, depending on what you choose. GraphPad Prism gives you lots of opportunity to choose between different styles. You just have to click on here. Change graph type, and you can play around different types of graphs. Okay, so graphs can summarize your data, Graphs can be individual values, box and violin. So see it's changing. Violin this way, violin straight. All these options are possible. Now, again, it's your choice which ones you want to show. Individual values are only useful when you have large number of values to show. If you have only 3 values, it's meaningless to show the distribution of your values. Okay. But if you have large number of values, very good. You can show the distribution with the mean or median. Yes. I do. Yes. Is one P value. Ah. Actually, you should do both. Yes. Along with degrees of freedom. Because what I'm saying is sometimes. I'm sorry. So what happens is sometimes if you the correlation was 0.45, but the p-value was highly significant, less than 0.01. So if you only put the p-value, you are giving an impression that your test is highly significant without giving an idea the correlation is not that much. For correlation regression is very important. So for example, those who work with genomics, proteomics, any omics kind of field, they have a large amount of data. And just by chance, data becomes significant. Maybe less than 0.0001 level significance. But if you look at the actual correlation will be 0.2, 0.3 like that. Actually, it's called correlation. So you should put the test name, comma, the test statistic, comma, degrees of freedom, comma, p-value. Entire thing should be there. Yeah. A value. No. F means ANOVA you are saying, right? So ANOVA F value, you have to put 2 degrees of freedom below F and then write the actual F value. Then comma, P value. That's all. Yeah. So that depends on which journal you, what is your purpose? Sometimes it go in your favor, sometimes don't go in your favor. Ultimately, if it goes in your favor, you show everything. It does not go and journal does not require, you do not need to show. Then you have to show. So that's why people are getting more and more smarter. That's why they are asking. They want to see that interaction is less or not. Because ideally, your 2 factors should be independent of each other, as less dependent on each other. Right, that's right. Okay. Any other question? Okay, so we'll stop here and I'll send you the brochure whenever I give the workshop. Maybe sometime in summer. Okay. This summer, but coming summer. Thank you.
That indeed would have been an insightful session. Thank you, Dr. Das. Next, I would like to invite Dr. Sundar Priya to kindly hand over the memento and felicitation to Dr. Das. Over to you, ma'am. Before we proceed further for the further sessions, I'd like all the attendees to take a 15 minutes break to enjoy the refreshments provided and also to refuel yourself. Please gather and assemble in the hall after 15 minutes. Thank you. Meantime, it is also requested that the software has to be downloaded. Link has already been shared. And when we talk about Zotero and Mendeley, so we need to download the desktop version. Okay, hopefully we have shared the list of software links. Hopefully everyone has installed. Okay, so go to any one of the databases, either like a PubMed, as I said, ProcVest, any of the database, and download 5 articles, which is like in a PDF or whichever. Download and save on your desktop, make one folder, in that folder only add 5 articles and keep on the desktop. So here the point is why reference and citations are important. So why this is important? So in the complete research journey, so references also has a crucial role as we are having review of literature. When we talks about the review of literature and the introduction and research methodology, results or finding parts, similar, the references and citation has the same weightage. If you are lose one, so you cannot be carry forward the complete research life cycle process. And this references gives the evidence for the statements or the kind of statement evidence we can be used. So whatever, for example, I can also give the statement for the one topics, but that will not consider as weightage as references because there is no citation, there is no literature. So when we do in the literature, we will cite as a part of evidence. So I am pursuing this area, this many work has been done, these are the method has been used, these are the finding has been done. So these are the evidence. Along with that, when we use references, we will say you are acknowledging, you are thanking the author because the idea, the work, the original works comes from the different authors. Their works, we are using it. So that's the reason we need to give a acknowledgement, credit to the original author. That's the reason we needed reference. So in case, if you are sending your journals to any one of the, if you are sending your article to any one of the journal, so they will first look at your references. If your references is complete, if your references are correct, if you are followed any kind of a standard, international standard, which is disclosed in the author guidelines, in the journal guidelines, they will going to be accepted. By looking at your reference itself, they will be reject your paper. It so happened that, so twice it's happened with me only. So I was sending a paper to the IGI Global, that is a very international database. So when I sent, they said only one thing. So you have prepared the paper well and good. That was my initial paper. So, but references you have not maintained properly. It looks like you are copy pasted from the somewhere else. So how they will get to know? So whether like manual people are there, they are going to be check individual references and all? No, they will not going to be check individually. So nowadays, article submission discovery will be there. Article submission platforms. So you might have seen elsewhere as well, there is a platform where you need to be upload your article. Okay. So even IGA also, they'll ask you to make 4 folders. First is like about the authorships, affiliation with affiliation, everything in the separate, and major introduction, major subject, major manuscripts is a different, and third is your references. When you upload the references in the system, AI will deduct this reference is not maintained properly. That will deduct and it will give fraction of second this error. By seeing that error, editor will send the paper back. By saying that your article is not going to match or else like references are not maintained properly, you need to be modified and send it. Okay, so that is the reason references are very essential. Okay, so third is, first is
we will going to make it as a evidence by citing our articles. Second is giving the credit to the author, and third is maintaining the uniformity. Okay, that will reduce our rejection of the papers. And the fourth is, the very important is plagiarism. So when you're not citing properly, randomly if you are citing, for example, 2024 articles are there, 4 articles are there. So I'm writing one article, so 4 I wanted to be included. That 4 also, it is their DOI. It means that article is available in the DOI, online, web format is available. AI will deduct within the fraction of second from where you have taken, how much % you have taken. Okay, so the cited, for example, somewhere the result part you have taken, but you have cited your own article. Self-citation you have done. That is completely wrong. You also know that is not my work, it's somebody's work. Instead of that, by mistakenly or unintentionally, that's added my self-citation. That is also going to identify by the AI. So this article, this paragraph is taken from the so-and-so article and cited, self-cited. That is also fall under plagiarism. So in order to avoid the plagiarism, we need proper reference management. These are the more useful also there, and nowadays these references are very essential. And when we talk about the references, there are international standards are there. Okay, so here we will going to be identified. There are few databases where we blindly copy paste the citations. Okay, how we will be rectify those things, and the reference styles are there. International styles are there, such as API style, NLM style, and Chicago style, IEEE style. So there are different styles are there. Since we are working for the multilingual and multidisciplinary research. For example, we are there in the pharmacy, but we will collaborate with the IT and we will write the paper on the IT. So if you are planning to submit your paper, since the paper belongs to the IT, you need to be submit in a IEEE. It means there are also for science and technology and the computer science, there are standard format which they will follow is IEEE reference styles. And when we talks about the medical, Vancouver style, and again social sciences, let's say APL and MLI, different styles are there. So when we talks about the references, one we will see in a web base. So for example, Google Scholar, PubMed, okay, they will give their article. In the down also, they will give cite this article. That means that is a web-based online citation. And again, you are having desktop application, which we can, today we will going to see 2 open source softwares, Zotero and Mendeley. So in the desktop, how we can be collect the literature, store and manage and retrieve. So those things we will going to see. And again, when we talk about the references, we are having MS Word plugin. If you are working in a MS Word, you can be directly cite. If you are working in a online, directly you can be cite. If you are working on a desktop, directly you can be cite. And again, if you are working with the Google Chrome, okay, in the search engines or the browsers, so that is also we have a browser plugins. So that we will be looking to in upcoming. Here, there are 3 terms are there. So as I said, reference, bibliographies and in-text citation. So are there 3 are similar? Are 3 are similar? References, citations and bibliographies? No, there are differences are there. So in-text citation means inside the manuscripts. So when you are writing the introduction part or the review of literature part, where you will going to be cite. If you are citing to the social science paper, you will be write author name. If you are citing for the medical paper, so then you are having numbers. Okay, 1 number, first article, second article, third article. So those things are in-text citation. Inside the manuscript you are citing. References means end of the manuscripts, which we will be all the literature papers. That will be there. As supporting that, this article has taken from the, this is the bibliographies. What about the bibliography? Bibliography is collection of cited and non-cited papers. For example, I have gone through some website, I have gone through some newspaper articles. I don't know how to cite here, but I have referred. Okay, I referred, but I don't know how to cite. There is no option to cite a newspaper. There is no option to be cite my reports, rare books and all. So then I should not leave the same. If you referred, add it as a title, as a bibliography, references and bibliography, add cited documents also, non-cited documents also. But you have referred, not cited. Okay, so those are the things we can be cover. And the main thing is citation and references. Where and all we can see? Where and all we can see? Usually. And are there any dedicated databases are there or dedicated platforms are there from where we can be collect? Are there? That is management tools. Okay, directly we can get the citations. Yes, it's there. So for example, Google Scholar. It's a kind of database, right? Literature database. PubMed, literature database. Web of Science, bibliographic and citation database. Okay. So in a PubMed, whether we are having articles, in the down only, we are having citation option. From there also we can be copy paste, isn't it? So from literature database also we can be copy paste. And second, journal. Okay. So suppose I have published my article, so that will be there on the journal website. In the journal website also there will be as site for this article. So that is also we will going to be look upon. So those are the places, platforms are there where we can be find direct citations. Rather than going to be other citation, direct citation will be there. Suppose imagine the book is published in a 15-year-old, but that is a reference for me now. So I wanted to be add that book or like any materials. So how to add? Since there is no literature, online literature on the 15-year-old book. So how to add that one? For example, conferences happen. So some conference they will be not going to publish a conference proceeding. If the conference proceeding will be there but not online, that's only for the half and printed and they will be circulated and after that is over. There is no online, no nothing. But I wanted to cite that paper. It means we need to do the manual entry. Okay, so these are the manual entry, World Book Record entries and citing in international and uniform format. So these are the Mendeley and Zotero and other different tools are there. So from that we can be managed very nicely. So why we need to be, is there any difference between web platform and desktop platforms and all? For example, Mendeley web version also there. Okay, when you go, when you search, so automatically it will ask you. And as you said, from PubMed also we will be directly, we can be take. So if everything is available, PubMed and Google Scholar in other database, then why we need to be use Mendeley and Zoteros and all? Is it no? So when I am preparing the articles, if I search in the Google Scholar, I will get all the articles. In that only they are giving the option to cite. So I will copy paste the same and I will keep. So why I need to be installed that's a database, Mendeley and the Zotero, I need to spend the time. Huh? Management. It means we will collect from all the relevant literature from the databases. First is a collect, then you will be start organizing it, then you will start managing it, then whenever you wanted, then you can be retrieve. So that is the main advantages in the Mendeley and Zotero and the EndNote and RefWork and different reference management tools. If you are using any reference management tools, that's the main help is collect, organize, classify, however you want, cite wherever you want, and use whenever you want. When it comes to the databases, on the moment you need to be used, after that you need to leave. Once article is published, and after that again you are writing the same article under related references. Again you need to go and search again. Okay, so the duplicate work can be reduced if you are using it. So as I said, There are desktop applications are there and web applications are there, which is available in online, and MS Word plugins also there. By using MS Word plugin also you can manage your all the references and the citation in these things, and the Google Chrome search engines also there, Google Chrome plugins also there. Then what are the literature databases are there, which is providing the references and the citations. For example, we can see Google Scholar, IEEE, PubMed, ProQuest. Okay, and a few of them they have seen also. And the ACM Digital Library was there. And the LitMaps will be there. That will give, and the Sciencebase nowadays, which is an AI based one. If you search even single article, that will give lot of information to you. It will give exact information as well, since that is a AI. Okay, so these are the different, more than that literature databases are there. Here I have mentioned because a few of them is subscribed from the NAPOIA. If you are using this, that you can be get exact and accurate information. Like we have a ProQuest one, ProQuest Central, if you are using it, Web of Science if you are using it. Okay, so Web of Science and Scopus, whether they will provide the reference? Web of Science and Scopus. Web of Science and Scopus, those both are like just bibliographic and citation database. Okay, but not reference management tools. Okay, they are very intelligent. What they did actually, if you really wants to be manage your articles, then they come up with a different product. Okay, that is which we have Mendeley. Mendeley is the product of Elsevier, as well as we are having Clinical Key Elsevier and Scopus Elsevier. That's a free. When we talks about Web of Science, they also develop their own product, which is called EndNote. Okay, EndNote, that's a paid one. You need to pay, then only you are having the subscription. Since last year, we had a subscription of a EndNote. Okay, see. So, I have such one article in the PubMed, which is like again literature database, where I wanted to be cited. Here they have given the option to cite, isn't it? So, you guys have gone through this process. So, where they have mentioned the reference styles. How many styles are mentioned? NLM, it means National Library of Medicine, API, MLA, and AMA. So, where is the Vancouver? If I want to cite, since I am coming from the medical background, I want to cite more option. Okay, where is the Vancouver? So, randomly what we will do? NLM. Okay, National, which they have given, Library of Medicine. Whatever they have given, we feel like this is the Vancouver, it's better to be copy paste. So, usually we will do that. I don't know how many of them they are doing the same. So, we will copy here and we will be pasted in our references. That is completely wrong. Okay, so here there is no option, more options are there. So, that is the reason we need to use reference management tools. Second, when we go to the journal site, here in this article, PMC Medical Ethics, that is the journal. When we search, according to the journal, they will ask us to be cited. So whether this is at the Vancouver, this is the Vancouver style. So here also, they have not disclosed which style they have followed. It means it is also not good practice to be followed, these sites. And again, when we talk about the Google Scholar, so here also option is there, you can be cited. Okay, so they have already categorized which style it is. It means overall, majority of them, they are preferring MLA, APA, Chicago, and Harvard, and Vancouver. It means the Vancouver is there. That is a correct? This is a correct citation? Okay. So since we need to study like one semester completely about the references. So that is the reason on the spot only we will be decide, no, this is not the correct. So since those who are not having the knowledge, it's a very difficult to be identify whether it is a Vancouver or not. So that time we need to be use our reference management tools. So I have taken the same one articles and I have just to go through and identify what are the mistakes are there. So first article references was in a Zotero software, which is reference management tools, that is given in-text citation as well as reference to me. It means in-text citation is 1. Okay. To the same, it's given. It is extra information because already they define the fields. In that field, whatever it is added, it has to be in that field. If it is empty, that's fine. Okay, but it should not be extra information. If it is extra, that will be deducted as an error. It will not allow you to be uploaded. So this one and PMC medical ethics, that is from journal site only. So again, they have given the URL and there are little slightly, okay, in italic. In the journal, always we write in the italic. That is applicable in the API. That is the API style one. So why it has come here? And again, Google Scholar. It is also carried the same full form of the medical. Okay, that is small, for us it's a very small things. When we are giving to the journal, for them it's a big deal. And again, I have added in a Mendeley and the ProQuest Center. In the ProQuest Center, what will happen, since this database is a subscribed one, when you are copy pasting the citation, it will carry from which university is a subscribe, from where you have taken. It means in the URL, you will get NAPOA full address. Okay, so that NAPOA address is not required, isn't it? The subscription, all the details will come. So from this database, this is the timings you have accessed. So that again we need to be set as a manually we need to work. So rather than that, if you are following any one of the reference management tools, this can be avoided. Okay, these are the many open source software tools are there and the commercial softwares are there. So just to be in touch with the central library. So what are the new reference management tools are there, and if it is the paid is there. So try your level best to be just learn and install, because no, in the paid you are having much more option rather than open access, isn't it? So we are working on paper. So we try to identify in the complete research life process and the research life cycles, what are the AI tools are there. We have come across more than 80 tools. 80 tools which is helping in a different purpose. For example, some tools are helping only for the checking the plagiarism, grammar and proofreading and the content development and giving the citations. And some of them that is helping in interview data translation. Okay, some of them they are going to take the interview, very old people will be there. If you are taking, you can be used like your recorder or something else. How you will be translate? How you will be take the same data? So nowadays AI is there. So that is helping a lot in order to enhance our research. So there are few of them. So I have listed over there. And AI-based reference management tools. Okay. So if you wanted to be explored, you can be explored. Sciencebase is the very best where you can be take the, even we have done the comparison as well. Okay. So whatever the references we will collect from the Sciencebase is correct or not. Recent data from the 2024, they will give full correct information. Okay. When we talks about the old data in the 1999, okay, even though from 2022, the data and the references are a bit difficult to take. Okay, so there was no DOI and there is no middle format. So they have not maintained consistency. In the 2024, if any articles are there, you can be taken from the science page. Okay, so coming from the same as it is from Central Library, here I would like to say, if you are pursuing your PhD or a research, these are the research support services you can be availed from the Central Library. So for example, we are having up-to-date databases that is also evidence-based. It's a very huge and biggest database. Again, we are having Web of Science, citation and bibliographic database. And if anybody requested to install Mendeley and Zotero, you are most welcome to the Central Library. We are there and we are ready to be help you in the installation, and IRNS will be there. And again, we are having, so the good news is, I think so everybody has received the mail. So plagiarism check in the Turnitin is a free. You guys have received some of them. Okay, if they are not, shortly that will come as a free. And the Trilpid is there, that is also plagiarism check software only for the thesis, only for the UG. If it is a PG, then I think so some sort of amount will be there, they need to pay for the thesis. then they can be get it done with the help of Turnitin. In the Tailbait and I authenticate. So they are the one who will going to identify your AI content. So reduce your AI content. Do not make directly generate the content. Okay, so that practice is completely wrong. So whatever the information you will upload, in the same query, if I give, I will also going to get the same answer. If you are published first, if I publish second, so that will come as a AI only. So AI we can use only for the assistance, not for the complete generating the data. So that we can be used, even though some of them have experience, I think. Those who are submitted as a UG dissertation and thesis, they need to go for the plagiarism check and AI deduction. So that time from Central Library, we will produce the report, how much deduction is there, how much and which line you have copy pasted from same. For the plagiarism is the same. So if you are copy pasting any content continuously 14 lines, it means that is considered as 1% plagiarism. So that has to be reduced. So if you are taking, or else you can be reduced by giving your parenthesis. If it is a quotations, give the proper quotation. Okay, if it is a citations, then give the proper citation with the brackets, inverted comma. Okay, some of the tricks are there which you can be used and you can be reduce your plagiarism check. Okay, so today I think so almost all done. So we will go for the live demo now. So hopefully everyone is installed. So articles are downloaded. Okay, fine. So typeset.io means, what is the extension? .io. Huh? So nowadays they started from AI. So wherever you see io.io, that means like the portal or the application is backend is a AI. Okay, so this is a site. What you can do is that SciSpace you have got everybody. Okay, so take any one of the article title, or else if you feel like not exactly the title, you add your area of interest. Done? So here there is an option, the SciSpace. So first you can be search your current literature, one thing. So in order to search the current literature, we will be completely rely on the Web of Science and Scopus database, because that is the authenticate, and we will be get, if it is published today and within the fraction of second, that is indexed by the Scopus of Web of Science. That is there. Not even full text, minimum bibliographical details will be there. So that is the one way how to identify the current literature. And second, we will go for the Google Scholar, or else like PubMed. So they will also take a time to be get index. So in that moment, what we can do directly, we can be use the SciSpace where I have entered my area of interest. So once you can be searched, and second, you just upload your any one of the, if you feel, so I'm unable to read now, it's a better, I don't want to read whole article, I just wanted main idea, what is there. So in that case, what you can do, save that PDF and upload the PDF here. So that will categorize all the information. For example, highlights, main highlights. What are the main highlights are there in the PDF, in the research? What is the main abstract? What is the main method? Okay, what is the main results? Okay, what is the main graphs which they have used? So that will give within the fraction of second. It will very easy for you to be prepared the review of literature based on your objectives. For example, you are using some sort of method. So you are just searching. I just wanted to know how many articles are there who use the same method. So here you just mention the method, title and method. It will be identified, it will categorize and give to you. Even 2 lines, 3 lines, you ask even question, what are the extra things are there? What is the main result? You guys can able to see there? No? You guys can see it, right? Okay, from your end only, you can be checked. Even you can be upload your PDF, any one of the PDF, you can be asked what is the main result in this PDF. Ask what is the main result in this PDF. That will automatically, that will give the answers. Along with that, you have again plagiarism check. So once your manuscript is done, you just upload there only. Okay, there is a left option is there. You guys can see plagiarism check and paraphrasing, proofreading. So majority of the things are there where you can be utilized and copy paste the same content and ask for the paraphrasing, proofreading, and same as it is, you can be cite. The paper also there, and down there is an option called cite. So from there, if it is a 2024 papers, you can be directly copy paste. If it is a older one, do not prefer this cite for the references. Fine? Okay, suppose I am working on COVID-19. What are the impact has been done in especially Karnataka region? So how it's got affected? So what are the new initiative has been done? So then which database is there where I can be prefer? Especially COVID related data. So one or another way, we need to be cite COVID-19 papers also. In those years, what was the condition? What was the trend? Isn't it? So in that case, what you can do is that there is a site called, is a completely COVID-19 database. See, for example, I have added my area of interest as a digital library during COVID-19. So it has given completely how many articles are there and how many review papers are there. If you open individual papers, there also there is an option called a cite. So completed. You can go with lit maps. Lit maps, that is also another database which will help you to identify what exactly your reference is and how it is connected to each other. For example, if I uploaded one article which is like 2024, in the 24, rather than checking manually how many other articles has cited by the same paper. So that will give the graphical and visualized picture. So that you can see. Sorry. It's okay. I will collect from Javed sir also. So here you will get just idea what are the tools are there which will help to manage, at least manage your references, web-based tools. So once you will go back to the home, you need to be explore. Okay, what are the different elements are there? What are the different advanced techniques are there which you can be explore. Here we will focus only to and mainly and Zotero. Okay, so here Bitmap, this is also kind of web-based tool. So you just give your area of interest here again. Type. If you know any article, you can be copy paste the same article. Or else if you have a DOI of any article, add it to the done. Suppose I will take only one article which is like 1991. In the 1991, I'll upload that article and I will try to identify what are the different references added by the specific article. For example, this is my single article, 2024. So in the 2024, see, this is my original article, which gives the years where you can be take recent year articles. See, when you are writing papers, be careful with the year, recent papers, and your references, and your journal selection. If three are done, everything is fine. Okay, when you are, even journal side also, they will, editors will check three things. One is main content, what you have done, what you have written inside. Tables, graphs, whether generated properly, whether visible properly, and then references, which is maintained properly or not. And the last is recent articles, whether you are aware of recent articles, whether you have added 2024 in a last month published articles, whether at least you have referred the abstract, and that based on that abstract whether you have added or not. These things are very important when we are writing the articles, then we need to be send it. And this is another site where the reference can be seen in the form of maps. Here you can be identified easily. 2022 article is the 2024, but they are cited different year papers as well. I will directly go to this paper. So you can select directly by clicking. Okay, this already, this is there. You no need to be go again and search for the 2023, 24, which is added old one. No need to go. Here only, if you click once again, that will explain you, see 2020. So I don't want to go somewhere and search again. You just give the double click. It will ask you in the direct. So this is the article which you are looking forward. If it is yes, give the double click. And in the right side and left side, you are having the pan where the abstract level information will be available. So here only you can be read whether this article is suitable or not suitable. If it is yes, this also you can be start citing it. Isn't it? So explore more about these online sources. This is a one, I feel like this is a bit okay. When you are initial stage, if you are starting your article in order to identify the trends of the research. Okay, so citation of the papers. So sometimes the papers are very good and some papers are like very good in the matters, everything is written, but citation is a zero. It means nobody has referred that article. Okay, if you want, you can be cited, but if you are cited most cited papers, that can give the weightage. So how to identify whether it is a more cited or not cited, whether this information is available in the literature database. For example, if I go and search in my specific domain, I will get minimum like a 2000, 4000 articles I will going to get. In that 2000 and 4000, which is the most highest cited? How I will going to know? Okay, so in that case, PubMed, if you are preferring PubMed articles, there is one kind of tool which they have used. CoSites. That is a tool called CoSites, which is there as a extension. You can be just search. Yeah, before going there. So here, what you wanted in these journals, articles, or like institution-wise you needed, okay, subject-wise you needed. If you want to, you can be selected by subject also, and a publication. I need just a publication. Just I will click. Here I'll add my same area of interest. See, these are the articles are there, where you can be, see the same individual article also you can be. So AI in a healthcare. So related to AI in a healthcare, how many journals are there? What are the main topics which is covered? Okay, and how many institutions are contributed? Who are the funding agencies are there? And how many countries are contributed for the same? And how many subjects are there? And how many publications are there? This also going to give the complete so this tool also going to give complete visualized type of information. Okay, you can be explore little bit. The thing is like there is a internet glitches. So unable to download even. See, when I added the terms called pharmacology, so it gives more than 4 lakh literature. Okay, so in that literature, which article is most cited and referred article? How to identify that? So here, none of the database is going to give the same information. In that case, what you can do, there is a Google extension, Google Chrome extension that is called CoSites. If you add it, just you need to, what you need to do, add Google Chrome extension. Just give the add. So that will come as same as it is, you can see here. So now I am unable to see any kind of top cited articles over here, isn't it? So in the right side, I am having the extension. Once I click the extension, So automatically you will going to get a counts here in the down. So based on the count, you can be saying these are the articles are very cited paper. Even though it is a very good paper, it's better to be refer. Okay, from your end, you can be explore the same. What you need to do, you just need to go to the Google Chrome where you need to be add, type as a core site. So in that core site, you just need to give the add extension. Once it's done means whenever you are opening PubMed database, where again you need to be click the extension. Once it will be clean, automatically that will give the countings. Okay, so how many? This specific journal and this specific article, how many times is it cited and not cited? 0 cited. I don't know why it is not working at all. Okay, so this is all about web-based application. Now we will go through directly to the Mendeley and the Zotero. Hopefully majority of them they have downloaded. Just open your Zotero desktop. So there is a difference between desktop, web application and MS Word plugin, and again you are having Google Chrome or like search engine plugins, isn't it? So now we will going to look upon the desktop. So here you can see this is a Zotero. So I will double click now. And the same as it is you are having Mendeley. So this is the web page of desktop Zotero. Okay. So here, if you are a PhD scholar, you may having a different kind of objectives. Based on your objectives or key terms, you can be prepare the folders one by one by clicking new collection. Here I will make one collection as a workshop. Done. Workshop folder is done. Once it's done, so now you guys have downloaded article, right? The desktop, and select the one article DOI. You can be select the DOI as well and the PubMed ID. So suppose 2015 article is there. Okay, 2015 and around 2000 articles are there. Whether each and every article has a DOI? No. So then what to do? If there is no article DOI means? See, suppose whatever we read, so that we need to be cited. That is our idea. So now 100-year-old books are there, 50-year-old books are there. If a person working on a historical perspective work, okay, he may going to be cite very old documents. So those documents are not available in the online. So that time what to do? So in that case, see here DOI is there. You can be copy paste the same because since this article is a new. Go back to the Zotero again. In case your article is very old, what you need to do? Need to go to the file and from there book section, and what are the elements you need to add as a manual entry. We can do the manual entry. For example, I am just read one case, I wanted to select that case. So now I have selected file. From the file, new items. After that, I will go directly to the case. I have clicked. So here, you are having the information you need to add as a manually. What is the case name? Okay, so what is the author? If you have abstract, you can add the abstract here. What is the count? So if you have the URL, you can be adding URL. In case I don't want to add book chapter, I wanted to add only for the interview citation also there. Okay, you can be need to go again to the file, new items, from you can select any letters or interview. So now, according to the interview, what is the title of the interview, to whom you have conducted, when you have conducted, what is the matter you have conducted, how long you have conducted. So those information you can add. If once it's done means, this is also very easy to be cited. Okay, so suppose I have an article, so which has PubMed ID and a DOI ID and ISBN, especially for the books. Okay, what I will do here, I will copy paste. So make sure when you are copy pasting the URL link, okay, DOI, especially DOI starts from the 10. Okay, so from 10 to here, or else if you are half full, let me see. Search. Yeah, in the back it's already it is retrieved. Okay, so same as it is, you can be retrieve your 5 articles. For example, second article. So in case some articles of yours which is not has a DOI, but you wanted to keep in a online with the help of DOI. There is a Figshare. There is an app where you can be generate your own DOI for the specific article. For example, your article is published in the conference. That conference is not in a online, let's say offline. So for that article also, you can be give the DOI, you can be maintain the same. This article has a no DOI. Okay, so suppose I have added 5 articles as well here. So now I wanted to take in-text citation as well. Inside the manuscript, in-text citation and the reference also needed. How to do? For example, if you are working for the, you have identified the relevant minimum like a 20 or 30 articles. Suppose you are doing a review article for the 30 articles. Your supervisor asked you to show that article. Instead of taking the printouts, what you can do is that you can generate the report. For example, instead of 2 here, so here I added just to 2. It may come for the 30 or a 40 as well. So what you need to do, just you need to be Control A, select, right click, here, generate the report from these articles. Fine. It will give the complete report. What is the title? So what is the main article? What is the references? What is the DOI? Everything will be there. Likewise, if you are having more than 30 or a 40, rather than taking your laptops everywhere, you can take the generate the report. You can sit and you can be work as well. You can read only for the abstract level. Isn't it? That also option will be there. And again, for example, now I am writing my article. Just imagine this is the content which is I am taking the result complete part I am taking from this article. Okay. So somewhere around I will read and I will little bit I will modify and I will be not going to be paste the same as it is. I'll modify. This is my original draft. But this idea is comes from that article, right? So for that, I need to give the citation. So here is done. So what I need to do? Yeah. Done. So I will go Zotero again. So that article is the first one or second one? Which I have copy pasted. That is the first one or second one? First one. That also we need to check. We cannot give random citation. If it is a random citation is given, in that specific abstract that content is not available, AI again it will be deduct, it will say this terms which is used for this citation, which is not there. It means the citation is wrong. Okay. So I have taken from here. So now I will go directly to the Zotero from first articles. I will select the first article, right click again. So here, create bibliographies. Create bibliographies. Done. Here it will ask you. Okay. So which referencing style you needed? If you are working with the science and technology paper, you can select IEEE. If you are working for the social science, MLA or APA, based on the general demand, you can be select here. And since I will take as a Vancouver style, even if you are sending a paper for the nature, so nature referencing style is a different. There you need to be select that one. I have selected from here. So here language you can be select. Whether you needed citation or references. Okay. So if you needed only citation, according to the citation, okay, you can be copied anywhere. I will take copy as a clipart. Okay, Control C. We'll go back to the same because I am writing in-text citation. Inside the introduction I am writing. Okay. It will give as a 1. Okay. So automatically it will come. So you guys have tried? Copy paste one. So suppose once you have gone to the Zotero, so this is the article are there. So in that article you need to give the in-text citation. What you need to do, first to select the article, keep your cursor on the article. So right click. So there is an option called create a bibliographies. Okay. So once it's click, so here option for the citation, select the citation, which one you wanted. Here you wanted citation or bibliographies. If you are working inside the paper, means introduction, review of literature, method, especially review of literature even, method, from the different perspective, you can be add in-text citation. When you are working for the reference in the last of the manuscripts, you can be select bibliographies and you can give, if you want, you can be take the printout. Usually copy to the clipboard and give just OK. I don't know why it is not working. You try from your end. Copy pasted. No? So in this Zotero, what we can do is that just we can be manage our content. That's it. So when it comes to the Mendeley is a completely different. Why this is the difference between Zotero and Mendeley is that, so Mendeley is the product of Elsevier. You are having a Elsevier publications, okay? So even a clinical key Elsevier and a Scopus Elsevier. So majority of the articles are Elsevier and that will going to be support in the Mendeley. Okay, so if you are taking Mendeley, means there are AI tool also there for the Mendeley. Along with that, the storage capacity, only for the, here it will be safe, if you want you can be safe PDF also. There also you can be save PDF. If you want to modify any kind of, if you want to be highlight anything, okay, you can be done by using the pen or pencil. See, this will be there for permanent. So storage capacity is a more in terms of in Mendeley rather than in Zotero. Okay, if you really wants to go for the reference tools, it's better go for the Mendeley. And again, we are having Zotero plugins as well there. Here you can be seen. So by searching also you can be cite properly. So now directly straight away we will go to the Mendeley. This is the Mendeley one. See, the collecting information from the different literature, from different databases and storing, organizing and retrieving. The process is the same in a Zotero also and a Mendeley also. But Mendeley has little bit advanced features. Okay, so you just open the desktop of the Mendeley. We can see this now. Huh? Desktop. Desktop version. Which we have saved on desktop. You just double click and open. Done. So here also the same. So if you want, you can be add your collection in the last, as I said, new collection. If you wanted, you can be add new folders according to your research terms. So likewise, I have added different folders. In each folder also, you can be upload your content. Fine. So suppose here I will be create one folder called workshop. Okay, created. In that folder, I wanted to be upload my 5 articles. How to do that? Huh? How to upload? And here also, automatically we can be upload the 5 articles. Okay, so likewise, just you need to be select your folder. Which one? Workshop. Done. So add a new. Add a new. Whether you wanted a manual entry, if it is 100-year-old books, you can be do the manual entry. If your articles are in a Zotero or else like in a PubMed, that also you can be exported directly. Now my articles are in the folder, desktop. So I will select the folder. So how many articles are there in the desktop? For example, workshop, sample articles. So Control A, select all the articles at a time, open. So can we see that articles that is getting update? So first what I did, I created one folder, I given the name as a workshop. By selecting that folder, I have just added new. In added new, I have just selected files from the computer. It means local folder. Done? Okay, so after that, it's automatically added. Fine. So now what we need to do, go to the tools. Go to the tools. In tools also there are 3 options are there. Okay, first you can be install your web importer. So once you will be install web importer, so automatically that will come to your browser. Like, so see, in the Google browser, it is there already. So when I click, when I search any of the article which is Elsevier, automatically it will give me full text if it is a free. And there, what I need to do, I just need to be add to my library, add to my library. If you add it to library, that will reflect in your Mendeley. See, this is the web importer. That also, that is a extension. If you search in the Google also, web importer for the Mendeley, you can be, just need to be click. Okay. So, again you are having install Mendeley site for the Microsoft Word. So suppose in the Microsoft Word also, Your Mendeley also in a Microsoft also it can be embedded. So what will happen if I am writing an article continuously? So I don't want to be interrupted. In that only I wanted to be start adding in. So in that case, if you are added plugin to the MS Word, that will helpful. So when you open your MS Word, so here, especially in the references, there is a reflection of Mendeley here. If you are installed. For example, I have added Zotero. Zotero web importer to the MS Word. See, in the last MS Word, it's there Zotero. If you want, it can be add, it can be cite. The things also be there. So another recently which they added in the Mendeley is that just tools and search for this article and online. Just click that. Just double click. Go to the Mendeley. Okay, tools, select the tools. In that, search for articles online. Just click, double click. So that will redirect you to the same. It means this is the platform of Elsevier. For example, here I am searching some articles. See, 2025. It means now we are there in a 2024. Then how article is 25? In the year of 2025. So how? Okay, so some articles are in press. It means in the upcoming year that article will going to be published. Before that, they will give the abstract level information, not the full text. Okay, so those articles, if you feel, okay, that is very important for my study based on the abstract, then that also you can be cited. Fine. So how many articles are there? 2024 related to the pharmacology. For example, here they have given citation. For this specific article, how many cited? See, here when I open this specific article, it is asking me to add a library. It means whatever I will going to add here, if I search, if I feel like it relevant to me, if I add to the library, that will reflect in your Mendeley desktop. Let me see whether it will reflect or not. So I feel this article is very important for me. So now I'll go here also option is there, add to the library, add. And likewise you can check other article as well. Whichever you feel, you can be search and just add. As he said, MS Word, Mendeley MS Word. Okay, this is a Mendeley site. If you are getting, you just need to be follow 2 or 3 steps. That's it. Here you need to be add your password and email ID. So this will be reflect in your MS Word itself. Okay, no need to go to the desktop and you need to be work from there to here. You can be work directly from this one. So here also, if the article is open access, you just need to be give the double click. If it is open access, that will be take you to the get to the PDF. Okay, so since this is not the open access, it seems, yeah, open access one. So suppose some articles are there which is like a subscribe based one. So what you need to do? You don't have the access for that. So that time, what you can see, whichever the free access one, you can make a separate folder and keep aside, and whichever it is not there, you can send to the article request to the central library. There is an email ID article request @napoe.edu.in. So if you send, you will be get a full PDF. That PDF also you can make it in a folder. Okay, so that folders you can be upload to the Mendeley for the permanent PDF. So see, this is paid one. Actually, what I did, so I have downloaded and I kept in a folder. That folder I have uploaded. So that's the reason, since this is a subscription, but I have a full text in the Mendeley itself. So another option is synchronize. So you can be synchronize your account with this one. So whenever your work is done, you just give the synchronize. Automatically, whenever you will open, all the article will be reflect. Whether it is a web, whether it is a online one. See, full text can be open here. And if you want, you can be add a new information. If you want, you can be give the coloring. You can be read. This will be there editing, and highlights will be there for the permanent. It won't get. So here also, so as I said, in this also in-text citation and the references is possible. In-text citation, again the numbering, which we can be give with the help of MS Word as well. So here, so we need to select the one article if you want to give any kind of bibliographies. So right click, copy formatted citation. Copied formatted citation. See, references added. For example, so this is the one article which is like 2023. I wanted to be added references for this. Select this article, right click and copy formatted citation. Done. So once it's done, go back to your reference site. From that side also, you can be copy directly. For example, second article also needed for the same, copied. Done. So just need to be copy paste from there. So suppose if you are having more than 30 or a 40 or a 50, you can be select at a time. Select all. Okay. So again, formatted and exports. Okay. So this is all about the Mendeley. So in the Mendeley and Zotero, the both are the same reference management tools. So where we can be manage our references. So in-text citation, especially and bibliographies. For the both purposes, we will going to be use. So if you want, you can explore more about Mendeley because that has more features. See, for example, if you added plugin in a Google Chrome plugin, so you no need to be go for the desktop. Here only you can be search. Okay, here only you can be search. What are the things I wanted? If you wanted articles, means you can be select from here only. For example, I needed this one. You can be view from here only. And finally, you can be set from here and you can be start adding it. Once you will be add here, that will be reflect to your Mendeley. So this is all about and the Zotero. So anything is there? So just to focus on Mendeley, especially by downloading, there is a handbook is there which I am going to be share. How you can be go step by step. Okay, so right from the download to till now to the manage. How you can be managed. So even online plugins, web applications, everything will be there. You can be managed only Mendeley. That can be give them much more. If in future, I think so in the next month, as they said, they're going to be subscribe even our EndNote also. If it is a EndNote is there means you can be having advanced features in that, then you can be explore more. So the basic EndNote that is a free. If you are working in a Web of Science, so collect same literature and you can be import to your EndNote as well. Okay, that is a free. If you are looking for the advanced, then only you need to go for the payment. So this is all about today reference management tools and all. So is there any questions are there? I know there is a, due to that internet connection, so unable to open the file itself. That's it. Yeah, thank you.
Any queries, any doubts? You can ask, ma'am. Okay, I hope you all understood about the reference management regarding Mendeley, Zotero and all. Thank you, ma'am. It was a very valuable session. Now I would like to invite Mrs. Fatima Begum to felicitate our chief guest.
Dear delegates, one small announcement. The feedback and assessment form and link, it is shared in the WhatsApp group. So kindly do the needful at the earliest, so we can provide you with the certificate at the valedictory function. Thank you. So now you can move for lunch counters and you can have your lunch. Assessment and feedback. At what time they have to assemble here? Kindly note, after your lunch, at sharp 2 o'clock, you have to assemble here.
quality and quality education. As a non-profit trust, the Academy established Yenapoya Dental College in 1992 and set up medical, nursing, and physiotherapy colleges subsequently. Over the years, institutions developed by this trust have created a niche in healthcare education, not only in hinterland of Mangalore, but also across the globe. In recognition for this contribution to the education system, in the year 2008, the Ministry of Human Resource Development, on the recommendation of the University Grants Commission, conferred the deemed to be university status. Yenapoya University thus became the first unaided deemed university to be established in the Dakshina Kannada district of Karnataka. The university, following the accreditation in 2015 by the National Accreditation and Assessment Council with an A grade, has diversified its academic prowess and scope by establishing Yenapoya Pharmacy College and Research Center and Yenapoya Institute of Arts, Science, Commerce and Management in the year 2017, the Yenapoya Ayurveda Medical College and Hospital and the Yenapoya Homeopathy Medical College and Hospital in the year 2018, the Yenapoya Institute of Allied Health Sciences and the Yenapoya College of Naturopathy and Yogic Sciences in the year 2021. Yenapoya University has secured accolades by various national and international certification and accreditation agencies. The significant ones being consistent ranking within 100 by the NIRF for 3 consecutive years. ATOL ranking of institutions on innovation achievement by the Ministry of Education locations under self-finance or private institutions category as an endorsement for the innovation and entrepreneurship development efforts among students and faculty of the university. The university has also been ranked with 4-star grading in KSURF Young University category in 2019. In recognition of contribution to the new knowledge generation, the university has been ranked among the top 50 institutions in India in the SCI MAGO institutions ranking consecutively during the last 2 years. There are multiple faculties of study in the university which are represented by the standalone constituent units. These institutions are spread over a total built area of 1 lakh.
We do not need magic to transform our world. We carry all of the power we need inside ourselves already. A very good afternoon to all. I, Halima Shine DH, Senior Research Fellow YPCRC, on behalf of Organizing Committee SRB, take this opportunity to welcome all the guests, delegates, faculties from various colleges, colleagues, friends, and volunteers to this valedictory program of 2 days National Level Research Methodology Workshop. Now, I request Organizing Committee Chairperson Dr. Muhammad Gulzar Ahmed and the convener Dr. Ruqayya Sultana and other HODs escort the today's chief guests and take the seat on the stage. Prayer is simply talking to God like a friend. It should be the easiest things we do each day. I request Mr. Ruknuddin, B.Pharm final year student, for invocation prayer.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم تبارك الذي نزل الفرقان على عبده ليكون للعالمين نذيرا الذي له ملك السماوات والأرض ولم يتخذ ولدا ولم يكن له شريك في الملك وخلق كل شيء فقدره تقديرا واتخذوا من دونه آلهة لا يخلقون شيئا وهم يخلقون ولا يملكون لأنفسهم ضرا ولا نفعا ولا يملكون موتا ولا حياة ولا نشورا وقال الذين كفروا إن هذا إلا إفك افتراه وأعانه عليه قوم آخرون فقد جاءوا ظلما وزورا وقالوا أساطير الأولين اكتتبها فهي تملى عليه بكرة وأصيلا. I seek refuge in Allah from Satan, the outcast. In the name of Allah, the most gracious, the most merciful. Blessed is the one who sent down the decisive authority to his servant, so that he may be warner to the whole world. Allah is the one to whom belongs the kingdom of the heavens and the earth, who has never had any offspring, nor does he have any partner in governing the kingdom. He has created everything, ordaining it precisely. Yet they have taken besides him gods who cannot create anything but are themselves created, nor can they protect or benefit themselves. nor can they control life, death, or resurrection. Thus, the disbeliever says the Quran is nothing but a fabrication which he made up with the help of others. They claim this is totally unjustified and untrue. And they say these revelations are only ancient fables which he has written down, and they are rehearsed to him morning and evening.
Thank you, Ruknuddin, for your heart-touching recitation. Today, we have with us a well-known personality in the field of research and higher education, a director of MPhil and PhD program, Yenepoya DMW University, Dr. Vinita R. Pai, as a chief guest. I request Dr. Aisha Sultana, HOD Department of Pharmaceutics, to welcome today's chief guest for this valedictory program.
Good afternoon, everyone. It is indeed a great honor for me to introduce and welcome our chief guest for the valedictory function of 2 days national level research methodology workshop organized by Scientific Review Board of YPCRC. Today's chief guest, Dr. Vinita R. Pai, is a woman of unmatched distinction and epitome of grace, strength, and determination. She is presently serving as the Director, Center for MPhil and PhD programs of Yenepoya deemed to be University, Mangalore. Dr. Vinita Pai pursued her BSc in the year 1981, MSc in 1984 from Kasturba Medical College, Manipal, PhD in biochemistry from University of Mysore in the year 2003. She has completed her postdoctoral research fellow from the Indian Institute of Science, Bangalore, awarded by the Department of Biochemistry, Government of India in the year 2007. She also has a postdoctoral fellowship from the University of Louisville in 2008. She also holds a postgraduate diploma in bioethics and medical ethics, Center for Ethics, Yenepoya deemed to be University. With this illustrious education and knowledge, she has spearheaded and authored 57 national and international publications with citations more than 630 and granted with Indian patent in the year 2022. She has received many accolades and recipient of awards like Teacher of the Year Award in the year 2022, received Best Research Paper Award from Yenepoya deemed to be University on the account of National Science Day 2022, Global Faculty Award 2021 for her extensive contributions to teaching and research, Award for Best Poster at the 9th Asian Pacific Congress of Clinical Biochemistry at New Delhi in the year 2022, Award of ICMR STS Fellowship in 2050. And with this brief introduction and glorious contributions of 33 years of experience in the field of teaching, I once again welcome our chief guest, Dr. Vinita R. Pai. Welcome, madam. Now I request our principal sir to present a sampling to our chief guest.
Thank you, Dr. Aisha Sultana. Yesterday and today, through this national level research methodology workshop, a series of sessions were planned and successfully conducted. To highlight in brief about workshop, I request Mrs. Rinjuna, Assistant Professor, Department of Pharmaceutical Chemistry, to summarize the event.
Good afternoon, everyone. The two-day national level workshop on research methodology commenced with an inaugural ceremony at 9 a.m. hosted by Mrs. Adija Bunia Mohindo. The ceremony began with the invocation by Mr. Misbah, student of 8th semester.
The Dr. Muhammad Gulzar Ahmed, Principal and Dean of YPCRC, then gave the welcome address by individually welcoming and introducing the chief guest of honor, and president to the gathering. The National Workshop on Research Methodology featured Dr. Anirban Chakrabarti, the director of NUCSER, as the chief guest, who delivered a compelling address on the novelty in the research field and effective approaches to pursuing a PhD. Following his insightful talk, the president of the event, Dr. B.S. Sripati Rao, honored Dr. Anirban Chakrabarti with a memento and the certificate, recognizing his valuable contributions. Subsequently, the guest of honor, Dr. Rekha PD, director of Yenapuya Research Center, shared her expertise on initiating research endeavors and effectively communicating research findings to the wider community. In recognition of her expertise, Dr. Muhammad Gulzar Ahmed, Principal and Dean of the institution, presented Dr. Rekha PD with a memento and certificate. The presidential remarks was given by Pro Vice Chancellor Dr. B.S. Sripati Rao, who emphasized the importance of quality and transparency in research endeavors. Dr. Rukia Sultana, Vice Principal of Yenapoya Pharmacy College and Research Center, expressed gratitude and extended a vote of thanks, closing the inaugural ceremony. Throughout this workshop, we had delved into the various sessions. The first session of the workshop began by Dr. Krishnanand Kamat, Professor of Srinivas University, on the topic Introduction to Research Methodology. In this session, he delved into the various stages of research process, elucidating each step from conception to conclusion. Notably, his guidance on formulating research hypotheses and crafting research protocols were particularly illuminating, offering attendees practical strategies to develop clear and focused research goals. Moreover, his provision of numerous research ideas and thought-provoking questions focused research goals. Moreover, his provision of numerous research ideas and thought-provoking questions added depth to the discussion, empowering participants with inspiration and direction for future research endeavors. Overall, the session proved highly informative and invaluable for aspiring researchers seeking to navigate the complexities of research landscape. The second session was by Dr. Sudarshan Kini, scientist from NUCSER, on the topic Research Design and Review of Literature. This session provided a comprehensive overview of essential elements in conducting scholarly inquiry. It emphasized the importance of crafting clear research questions, selecting appropriate methodologies, and designing rigorous studies. Additionally, the session highlighted the significance of conducting a thorough literature review to situate one's research within existing knowledge and identify gaps for exploration. Key takeaways included understanding various research paradigms, distinguishing between qualitative and quantitative approaches, and honing critical analysis skills to evaluate existing literature effectively. Overall, the session laid a solid foundation for conducting rigorous and impactful research studies. The third session was by Dr. Rashmi Jain, Professor of Yenapuya Medical College, on the topic Research and Publication Ethics. This session gave insight into upholding ethical standards such as various principles and guidelines including honesty, transparency, and respect for the intellectual property. The session emphasized that clinical studies need to adhere to ICMR guidelines and all clinical trials need to be registered in CTRI after obtaining ethical clearance from the institution or organization. The session also emphasized on plagiarism, fabrication of data, and proper citation practices to maintain the trust of academic community. It also highlighted the benefits of risk assessment, type of risk to participants in research, privacy, and confidentiality. Overall, the session empowered to maintain scholarly integrity, ensuring the credibility and reliability of academic work. The fourth session was by Dr. Yogendra Nayak, Professor of Manipal University, on the topic Manuscript Preparation and Journal Publication. This session emphasized crafting captivating titles and informative abstract to attract the readers. Discussion centered on effectively presenting results and drawing conclusions based on findings.
Special attention was given to tailoring submissions for both Q1 and Q2 journals, ensuring alignment with the scopes and impact factors. By adhering to this principle, researchers can maximize their chances of acceptance and make impactful contributions in their fields. The fifth session was by Dr. Sindhupriya E.S., Associate Professor of Yanapuya Pharmacy College and Research Center, on the topic thesis writing, where the session started with the introduction in which she explained thoroughly about what is thesis and what are the components of thesis. Later, she discussed each component of thesis writing, starting from the introduction to the reference. She emphasized the need for writing abstract according to the guidelines and also for the writing thesis in the active form. She concluded the session with 9 key points that should be considered while writing thesis. The session was excellent, which explained everything in detail regarding thesis writing with the time limit. This was the last session of the Day 1 National Workshop. Day 2. In Day 2, the first session of the day was by Ranajit Das, Associate Professor, Yanapuya Research Center, on the topic Biostatistics and Hands-on Training. During the session, attendees gained insights into the basics of statistics, particularly focusing on practical applications. The session provided a comprehensive overview of statistical concepts essential for research, including hypothesis testing, data analysis, and interpretation. Through hands-on training with GraphPad Prism, participants learn how to perform various statistical tests and effectively visualize their data using graphs. Key topics covered included data entry, selection of appropriate statistical tests, interpretation of results, and graph creation technique. Overall, the session equipped attendees with practical skills and knowledge to confidently analyze and present their research finding. The last session of the workshop was by Ms. Amreen Taj, librarian of Yanapuya Pharmacy College and Research Center, on the topic reference management and hands-on training. In this session, the speaker had discussed thoroughly about the reference management. She explained about the article submission platforms regarding different reference styles, reference and citation tools, literature databases, AI research methodology tools, plagiarism checker. She gave an excellent hands-on training about various applications like SciSpace, COVID Scholar, LitMaps, Wisdom AI, Zotero, and Menly. It was a valuable and enlightening session, and she tried to explain everything within the given time limit. Thank you.
Thank you, Rinjana, for insightful summarization of the program. I request today's chief guest, Dr. Vinita Arpai, to address the gathering and share her experience.
Hello.
Good afternoon, one and all. Yeah, I think everybody is very keen on finishing and going away after 1.5 days of intense sessions, as I understand from what the report was read. Let me start by thanking Professor Mohammad Gulzar sir, Dr. Rukia Sultana and their team for giving me this opportunity to share my thoughts with you at this valedictory function in the Yanapuya Pharmacy College. Thank you, sir and madam, for inviting me. So I feel that most of us don't go into research simply because we think research is difficult. We see the way other people work and we think this is difficult. This is not for us. If we go with the mindset that something is difficult, it is going to turn out to be difficult. When we go for a movie, we don't think that there will be sad scenes, so I'm not going. We hear the reviews from other people and we do go and see the movie, however sad it is, however happy it is, we go and see the movie. We pay money to see the movie, correct? That is because you are mentally prepared to see a movie. Same way, same physiology, the same philosophy can be applied to research. To tell you a simple story about Thomas Alva Edison. We all know Thomas Alva Edison as the man who made the lamp, the electric bulb, correct? That was not the only thing he made. He made so many things like phonograph. He made a motion picture camera for the first time. And how he made these things is really interesting. Now, onwards, his mother, who was previously a teacher, taught him maths, science at home. The only thing that was different in Edison as compared to the other children was, although he was not doing good at school, he was a voracious reader. Anything that his mother read to him, he could understand. And slowly he started reading himself. With the knowledge he got from reading, he started doing experiments. His main interest was chemistry and something to do with mechanics. Anything was mechanical, he would want to put it together, remove it out together. And at a very young age, he started his own laboratory in his bedroom. The mother had no issues with this as long as he didn't burn the house down. So he was using chemistry, small chemical experiments to do, and he moved to the basement of the house. That is how he started his journey of being a researcher. Slowly, he started at the age of 12, he was selling newspapers and small things in trade. And he found people were interested in buying newspapers. So he learned how to do that, how to make a newspaper and things like that. And then one day, he saved the child of the station master from going under the train. The station master was very impressed with Edison and he taught him telegram, how to do telegraphy, how to do write a telegram and things like that. So somewhere down the line, he decided that he should work for a newspaper. So he joined a newspaper company where he took a night shift because he thought daytime there will be too much disturbance. He may not be able to do research continuously. So he took a night shift. But unfortunately, he got so involved in his research that he missed oversight of sulfuric acid falling on the ground. He didn't realize that sulfuric acid had fallen on the ground. Next day morning, he got fired because that sulfuric acid had percolated through the floor and fallen on his boss's table. So he was asked to leave the lab. So what he opened the note and saw, what the teacher had written was, your son is dumb. He cannot be taught at home. You have to homeschool him. And the mother told him that he was a genius. See, just replace that dumb word with genius. And Edison turned out to be a genius. He said, genius is 1% inspiration and 99% perspiration. Not the perspiration we are undergoing now in this summer. It means hard work. So 99% is hard work, 1% is inspiration. So Edison can become a genius. All of us can become geniuses. Only thing is we have to put our mind to it. Was there no electric bulb before Edison found his incandescent bulb? Of course there was. But he innovated it. He took it a step forward. So what he did was the older bulbs were very time consuming to produce. They were run by oil or gas and they were using very expensive metals. He became very innovative and created a bulb which could be used by common man, which could be bought by a common man. Same way, he knew about telegram, he knew about phones, which Graham Bell had invented. He combined the two and came out with the phonograph. For the first time, he recorded in his own voice the nursery rhyme, Mary Had a Little Lamb, on tin foil, mind you. And he was able to record and replay it. But from small, he had a hearing problem and by the age of 12, he had lost his hair, most of his hearing, yet he was able to develop the phonograph. While he was doing all his inventions and becoming a researcher, he suddenly found that he has an aptitude for marketing his own products. So he started marketing his own products and he became a businessman. He started 14 companies. Till date, nobody has surpassed his record of 1,093 patents. He had 1,093 patents. Nobody has surpassed that. So from a dumb child to someone who could create 1,093 patents, 13 companies, it's a really inspiring journey. I think from this, we should take home the message. There are 7 P's in the course of the journey in research. First is being very passionate about what you want to do. Find your passion. Work more on the area which interests you. Second is planning. Plan your experiments well. Sometimes we don't know what to do. Tag on to someone who knows what to do. Learn from them. And then you can take the next step. Third one is performance. Once you've planned it, how well you do the experiment. Have you placed your goals? Are you achieving your goals on time? These are the things you should look for. Perseverance. Edison didn't get the incandescent bulb overnight. He did 1,000 attempts, and only in the 1,001 attempt, he was able to produce the perfect bulb. So perseverance is very important. Something doesn't work out, don't say it, nothing, it's not going to happen. No. See why it has not worked out, and then redo the whole thing. Patience is very, very important. You have to be patient till you get the result you want. Sometimes you may not get what you want, but you may get something better when you are very perseverant and very patient. If you do all this, you'll achieve a lot of progress in your research field. Then the last P, if you are fortunate, you may be able to apply for a patent. Okay? So these are the 7 P's that you have to follow when you are thinking about research. I hope you remember them. Do you? Yeah. So these are the 7 P's you have to look for when you are doing any research work. I'm sure you may think, why every year I should attend research methodology workshop? I can do something else at that time. Yes, we can all do something else at that time. But sharpening your axe is also equally important. There were 2 friends who joined a company where they had to cut trees. Friend 1, let's name him Nick. He was cutting the tree. He cut the tree. He cut about 18 trees a day. And slowly it became 12 trees, 10 trees, 6 trees. Then finally he ended up cutting 2 trees a day. He was there 6 months down the line. He was doing only this. The other friend who had joined along with him, within 2-3 months, he was promoted, and then he got another promotion. So at the end of 6 months, he was earning almost double what Nick was earning. So he decided to go and ask him. He went to Nick and asked, see, both of us joined at the same time. I'm also cutting trees, you were also cutting trees, but you got promoted, you got double salary.